Hi everyone, and welcome to our Migrating to Jetpack Compose code along. I'm Nick, and I'm joined by Manuel. Quick side note, I actually lost my voice 2 days ago, so I'm hoping I make it through this code along, but you've got a slightly husky Nick Butcher today. We're also joined by Jose Alferica and Nick Rao, who are in the YouTube live stream chat answering your questions. So if you're watching live, then feel free to ask questions there. Now, Jetpack Compose is Android's new UI toolkit, and it's built to coexist and interoperate with the Vue system, making it easy to adopt at your own pace. There's no need to rewrite your apps from scratch. You can start by adding a single Compose element to your app.
Today, we want to show you how you can start adopting Compose in your existing apps by live coding, migrating part of a screen from a Vue-based app. We'll go through the Migrating to Jetpack Compose code lab. Feel free to follow along in Android Studio yourself or just watch. To get the most out of it, we recommend that you are familiar with writing Jetpack Compose, as we will focus on the migration and interop APIs today. If you're not, we recommend that you check out the Compose Basics code along. Okay, so hands on now. Let me share the screen. Nick, can you see it?
Yeah, I can see your screen. Great. So you can find the code lab either by searching for Migrating to Jetpack Compose, or if you follow the short link, which is shown on the screen just below. Okay, so this is the code lab that we're going to work through today. There's a number of steps, and it will cover how to incrementally migrate your Vue-based app to Compose, how Android views and Compose can interoperate, and then finally, how to theme and test a hybrid application. So let's jump in at step 2, planning our migration. So there are many ways that your team can go about adopting Compose. You can consider either writing new screens with Compose, leaving the rest of your app Vue-based, or you could migrate individual components to Compose and use them from within Vue-based screens. Or you can migrate entire activities or fragments. It's up to you and your team to pick the best strategy for your app.
Today, we'll use a hybrid strategy where we'll start with a Vue-based app and migrate some elements to Compose. So what are we going to migrate today? We've created an app ready for you to work on. You can find the code in the Android Compose Code Labs GitHub repository. This repo contains code for all of our Jetpack Compose Code Labs. Today, we're interested in the Migration Code Lab. The Migration Code Lab is built on top of the Sunflower app, a simple plant tracking app that is currently written with Views. There are 2 branches of this repo, main and end. If you ever want to see the final results, you can switch to the end branch. I already have Android Studio with the project imported and the emulator open and running the Sunflower app. Here you can see our empty garden, and we can take a look at the plant list, where we can see plants like apple, avocado, etc. So for example, if I click on avocado, I can see the plant details. Today, we will migrate the information of the plant to Compose, the text that you see on the screen. That is the plant name, watering needs, and its description, nor the image or the fab.
So how do you add Compose to your app? This is already done in our project, but let's take a look at the build.gradle file to show you what you need to do to actually add Compose support. So here we are in build.gradle, and the first thing is the build features block, where we set the Compose support to true. What this does is it tells the Android Gradle plugin to add the Compose compiler extension, which is what Compose uses to generate code powering the Compose model of automatically re-executing your composable functions that you write whenever the app's data changes. Going down to the dependencies, we can see there's a number of Compose dependencies for different functionality. For example, there's the material artifact, which contains all the UI components we're going to use, as well as things like UI tooling for providing Android Studio's preview support. So, as we said, this is done in the project, but now you understand how to configure Compose, we can start using it. We'll start small, and we'll replace some views declared in XML with Compose functionality. To do this, we'll use the Compose view. This is a regular Android view that bridges from the Vue world into Compose. That is, we can create Compose within it. Even we can create a Compose view either in XML or in code, and then it offers a set content method in which we can create Compose UI. So Manu, why don't you show us the views that we're going to migrate? They're using data binding right now, right?
Yeah, that's correct. So we can go to the plant detail fragment, which is the entry point to the plant detail screen. And here we can see a bunch of things like using view model, the plant detail view model, to grab information, application data to display on the screen, and also perform some business logic. And in the onCreate view, we can see it's using data binding to inflate this fragment plant detail XML layout. So we can see what it looks like. We can see it's using data binding, exporting some data, and a coordinator layout that is going to contain the app bar layout with a collapsing toolbar layout. We are interested in that. And with the nested scroll view, that is going to give you that layout behavior. Inside it, we're going to have this constraint layout, which is what's going to have the plant information. We will say it's made of a bunch of text views. And this is what we are going to migrate. So we are going to select pretty much everything, the constraint layout and its content and its children, and we are going to comment it out. We are commenting it out because later we'll have to see how to migrate each individual text view to Compose. So to have, as you were saying, to have Compose content in here in an XML, we can use the Compose view type, which is going to be a view type, and we can give it the same width and height of that of the constraint layout, so we can have much parent. So to be able to reference this Compose view in the fragment, to be able to call composable functions, we're going to give it an ID. Going to be ID, and then going to give it Compose view, for example, because we don't have many other Compose views in here. And as you can see, we are not passing in the margin. We are not declaring the margin in the XML. That's because we want to have Compose as the source of truth, and have, for example, later we'll see how to add that margin inside Compose. We don't want to tweak things in XML and then Compose. Single source of truth, it's going to be Compose. So here we can go to our fragment, and in the apply block where we configure our bindings, we can go to the bottom of it, and here access Compose view, which is basically we just created. And then here we can call the set content method, as you were saying, Nick. This is going to be the bridge from the view world into Compose. So in its Lambda, we are in Compose land, and we can call composable functions. So here we can have the material theme just to style our Compose elements, UI elements. And inside here, we can call the plant detail description, which is going to be a composable function that we already have ready for you to work on. It's going to deploy this to the emulator, and we can see the plant detail description is going to have just a hello Compose. And here we are just making sure that we configured Compose properly. So in the emulator, what we need to see, or what we're going to see right now, it's going to be no plant information and just hello Compose to make sure that everything is working fine.
Cool. So while that's building and deploying, just a quick reminder, feel free to ask questions in the live chat at the bottom on YouTube, and we'll be answering them for you. So it looks like that has redeployed and it's launching. And hopefully if you go to your plant list, we should see that. It's always good to see the hello Compose text. It means that the build has been configured and everything's set up. Cool. Yep. Awesome. So let's go on to the next step. So now that we've kind of set everything up and got the plumbing in, let's actually migrate some of our UI. We'll want to convert the text view, which displays the plant's name and its layout and styling, to the equivalent Jetpack Compose APIs. If you're looking for a list of UI components that are available for Compose, then check out the material modules reference docs, which list them all out, then you can look them up. So while converting our UI, Android Studio's preview function will help us to visualize what it will look like, which means that we don't have to always deploy our app or navigate to a certain screen to see it.
Yeah, that's correct. So let's close the emulator and let's see what we need to migrate to Compose. Let me here. So basically, it's going to be this text view, which is going to contain the plant name. We can see that it's configured with some XML attributes that we will take a look. And the text, it's coming from the view model. It's going to view model, which is exposing the plant with live data and get the name. So that's going to happen in a later step. So we are not going to worry for that at the moment. So what we are going to do, we're going to have a composable and have a plant name. Cool. And so in the plant name composable, here I can also have, I can add the preview as you were saying before, Nick. I think, are you hearing me?
I hear you fine.
Okay, sorry. So yeah, so I have the plant name here, sorry, and let's assume that we are gonna get a name as a parameter. So here's gonna be the plant name. And as you were saying, instead of a text view, we can have a text composable. So in the text composable, we can pass the name. Cool. So, okay, so as you were saying before, we don't need to actually redeploy every time and navigate to the proper screen just to see how the plant name looks like on the screen. So for that, we can use this preview here. So let's create the preview with the material theme, and then we can call the plant name, for example, with something like avocado. And now we can open the preview and to make sure that, oops, there we go, to make sure that everything is working fine, we might need to build and refresh. And while that's happening, which shouldn't take that long, we're going to see which XML attributes do we want to map to Compose. So the first one, actually, is that rendering? Yeah. So we can see that avocado appear here on the screen. Okay, perfect. So, okay, so back to our XML layout, we can see that we have some margin applied to the start and end, which is going to be 8 dps. But these 8 dps are coming from dimensions, from the dimensions.xml file. This is going to be applying the margin small. And it's also going to center the text horizontally in the screen, and then we're going to give it some appearance. Cool, so back here, probably you know that we can style this text, we can modify it using modifiers. So we can have to give, for example, let's start with the margin. We can use the padding modifier. And padding offers different overloads. You could, apply padding to all sides, horizontal, or start, individual sides. So because we're interested in the start and end, we're going to use the horizontal one. And in here, we could actually hard code it and say, something like 8 dps, as we had in our XML layout. But since that information is already in the resources file in the dimensions, we actually can reuse it. And the thing is that Compose offers a bunch of helper functions to allow us to get information from resources. And in this case, the function that we need to use is the dimension resource function. We will see later that we have more of them. So we're going to do R that we have to import, dimen, and from dimen, we can get the margin small. So that's basically the way we migrated kind of the margin from XML to Compose. And the previous rendering, and we can see how it added a little bit of margin to the sides. Cool. Now let's see how we can center the item horizontally on the screen. For that, we can use the fill max width operator just to occupy as much width as we can on the screen. And then in addition to that, the grab content width operator as well. And that's going to take an alignment that we can say center horizontally. So that, again, that's going to give us, going to occupy the whole screen, the whole available size, the width, and then going to be centered that on the screen. Cool. So we can see that run fast, and we can see avocado center. Lastly, what we need to do, apart from the text that will come later, we need to set the text appearance to headline 5. And we can go here to the text composable and see the function signature. We can see that it takes a text that we already set, modifier, color, font weights, and the one that we're interested about, you can see there are a bunch of them. The one we're interested about is about this style, the text style. So we can actually set the style of the text, and we can grab different styles from the typography that is available in material theme. So in here, we can access and see the typography offers a bunch of different ones. And in this case, we're interested in H5, in heading 5. And so with that, I think if the preview refreshes, we can see the text a little bit larger here on the preview. Yeah. There we go. Okay, now it's larger. Cool. Okay, I think we're ready. We migrated the plant name to Compose.
Right, and we've got a couple of questions coming from the live stream. Let's take them here on the stream as well. So Dimitri asks, what about the performance when we embed Compose in XML? It should be good, right? Basically, Compose View is a regular Android view and participates. That's how we get all the layout information and the events coming through and pass it through into Compose Land. So it's doing some stuff, it's adding some overhead, but Compose itself is also very performant. The layout model itself and the fact that we don't need to inflate XML is very performant. So the goals of the compose system is to be like as performant, if not better, than the view system. So if you ever find any situations where we're not hitting that, then we consider that a bug. So please file issues if you're seeing performance degradations like this. So should be good, very much a goal, if not better, than the view system. Another question is coming from the live screen asking if you can progressively migrate to Jetpack Compose. Absolutely, yes. This is what we're doing right now. So having changed, a text view into a Compose view is kind of how we consider you can like take your first steps in Jetpack Compose by just adding a single component. That's kind of where we're up to right now. The goal is that you can, adopt it at your very much your own pace, a bit like the move to Kotlin, where you can, add a single file. We think we've taken the same approach with Jetpack Compose. Cool. I think that was the questions we got coming in for live stream. So let's go on and continue on with the CodeLab. Right, so now we can render a plant's name, but we want to actually hook it up to our app state rather than showing static data. So this screen's view model loads data and prepares it for display. It exposes a live data of the plant to display, which the UI can then observe. Now, we can easily consume this in Compose, which offers functions for observing streams of data like flows, RX observables, or live data, and converting them into composes of the observable type, which is called state. So, for example, we can use the observe as state function, which observes the live data. And then whenever this value changes, any composable function which reads that state will then be re-executed.
Yeah, that's correct. So here we can go to the plant detail fragment, and if we go to the top, we can see that it's using the plant detail view model. It's grabbing it. And if we take a look at the view model, we are seeing it's just a very classic view model that is grabbing application data, for example, the plant from the repo, from the data layer. So that plant is going to be exposed as a live data. So it is true that we can grab instances of the view model from the body of a composable function. But just to avoid the hassle of it, because it requires a factory and all that, because we already have the instance of the view model in the fragment, we can pass it to the composable function, and that's it. Like, we don't have to do anything else. We already have it available. So we're going to add that as a parameter to the plant detail description. And here, I wouldn't worry about memory leaks or anything like that, because the plant detail view model, the view model has a longer lifespan than the fragment or the composition. So we should be fine in that sense here. Okay, so now that we have the plant detail view model in Compose, what we need to do is to grab the current plant, that of the one that exposes the live data. So for that, we can imagine that we should have something like the current plant in a variable, and that plant is going to come from the plant detail view model. So as Nick was saying before, like, we need something to convert from that stream of data to Compose's state API. And we need that just to be able to recompose this function whenever this plant changes. And for that, we have the function observe as states. And actually, we can jump into the implementation of observe as states, because we are not passing in a state value. It can return, it's going to be a nullable type. And you can see that it creates a state that is going to be returned with remember mutable state of, so nothing new here. And then the live data, it's going to be, it's going to have this observer that on every new value, it's going to set the value of the state to whatever it receives. So this is how the composable function is going to be able to recompose, because we are mutating this state here. So that's a pretty easy implementation. So the idea here is that, for example, to not access the value of the state every time, we can use the property delegates with the by keyword. So now we can use current plant. We can guard against the nullability with the let block here in Kotlin. And inside here in its body, we're going to see a non-null plant. So with this, we can move this up. And instead of calling hello compose, what we want to display is the actual plant. So we can say plant name, we can call it like that, and then access the plant.name like this. Okay, so one of the problems with this plant detail description function is that it is coupled to the plant detail view model, which makes it hard to reuse in other parts of the app. The other problem is that it contains mutable states, that is the current plant, and it takes the view model as a dependency. It is also very hard to preview. The solution is to create an additional composable function that just takes what is required to display a plant on the screen. So, and that's here. We can take this function here, or this piece of the function, we can extract it out to a different function, and we can even call it in the same way. We can call it plant detail description. And so in here, we can have it like this. And you can see that here we have plant detail description that just takes what it needs, the plant name. And because it doesn't contain any mutable state, we can say that this function is stateless. And this other function that contains mutable state, we can say that is stateful. And so as we were saying, the benefit of the stateless function is that it's easier to preview and it's more reusable. And it's reusable because you just need to call pass a planting. You don't need to pass the plant detail bmodel. But the benefit of the stateful version is that it is opinionated. And it's because it's opinionated, it's going to be easier to call, for example, from the plant detail fragment. And so it is a good balance it's a good practice to provide this balance, right? Stateless and stateful, just to have that flexibility and use what you need at the moment you need it. So we're going to go and create a preview for plant detail description, because right now you just need to pass a plant, the plant that you want to preview. So let's come here and say plant detail description preview. We can pass in, as before, the material theme. And now we can call the plant detail description with the plant. Which plant? It could be something fake that we create. So here we have we can create a fake plant with avocado and the rest of the information. And that's what we can pass into the preview. So here, if we open the preview, we can click build and refresh. And we can see that now we can see the new preview on the screen. And now it's so much easier to change the fake plant or to use something different, because this is now very reusable. Cool, so we can see the new preview here on the screen. And cool, just to actually, like, this is the mock that we are gonna migrate. We're gonna migrate the plant name, the watering needs, and the information. Let's go ahead, and here we can imagine that we're gonna have the watering needs, and then we're gonna have the plant description. And this is gonna be centered vertically on the screen. So what we can do is use a column for that. So we can do Alt-Enter, surround with widget, and we can do surround with column. And actually, what we've done here, it's what we had before in the constraint layout. This is going to be kind of the outer container. And now we can add the margin that we missed before. So I'm going to copy this modifier here, and I'm going to add it to the column. So we're going to do, we're not going to be the modifier for the column is going to be applied to all sides, and it's going to be margin normal. And then we want it to occupy the max width as well. Okay, so basically we just migrated pretty much what we have in the constraint layout to have the outer container here in the column, just to be able to iterate quicker through the code lab. So modifier for max width, some extra padding, and now next steps are going to be migrating the watering needs and the plant detail description. So now here we can see how the preview also updated. Cool. I think we're ready to go.
Cool. A couple more questions come in from the live screen, so let's see. So David asks, why are the functions uppercase? You might have noticed that unlike kind of regular Kotlin functions, which are camel, Pascal case, I always forget, lowercase starting with. We tend to, this is actually a Kotlin idiom that we borrowed for Compose, which is when you have kind of like a factory function which constructs an item, then they recommend to use this kind of uppercasing. It's used in some of the coroutines APIs, I believe. And so we actually borrowed this because you should consider these composable functions are basically like factory functions for creating these UI objects. And as such, we give them this kind of uppercase naming. Mm-hmm. Another question is coming in from Jeff of like, do we need to migrate styles to Compose to use them, or are styles already defined? Can we use styles already defined in XML? Maybe we should save that one. We're going to get to that one a little bit later on, but it's a great question. So you're thinking ahead there. Right, should we carry on with the code lab, Manu? Yeah. Right, so far we've hooked up our UI to our view model, to our application's data and state, and we started converting some views. So we converted the plant's name, and we put in the layout container as well, the column, to replace the constraint layout. Let's see if we can quickly build up the UI using Compose's layouts, modifiers, and styling APIs, and how we can interoperate with more of the resources system.
Yeah. So what we're going to do now, it's pretty much showing the mock again. It's going to migrate the watering needs, and this is what we're going to do in this step. Okay, so for that, we can create something we can call plants watering, for example. We can call this function. And as our mock say, we're going to have a column again, because these two texts are going to be displayed vertically on the screen. So we're going to have the text say watering needs for now, and then something like every X days. So this is pretty much what we need to do now. And actually, let's call it from here, from the parent one. Okay, so plant watering. So let's go back to the XML, because we're doing like a migration from XML layouts to Compose. Just to iterate on this quicker, let me split the screen and move the XML down. Cool, so this is gonna be plant detail name. Okay, plant header. This is the text view which corresponds to the watering needs. So same as before, so we are gonna have start, top, and end, margin small and then margin normal. So I'm gonna copy again this modifier here. So the text for the watering needs is gonna have the modifier with horizontal margin small. We can copy that, and then we're going to apply the margin normal, which is going to be applied to the top. Okay, center horizontal. I mean, this is going to be applied to both texts, and actually we can make use of something that column has, which is something that is a parameter, which is the horizontal alignment. And in the horizontal alignment, we can say center horizontally. So every children of the column is going to be centered horizontally. We don't have to specify that in every single child. Cool, so that's going to be in there. Now the text is going to be watering needs prefix. And this actually comes from the strings.xml file. So we actually don't have it hard-coded here. As I was saying before, Compose offers methods to access resources. And similar to dimension resource, we have the string resource function, which is the one that we're going to use, right? So our string and then the watering needs prefix. Okay, another XML layout here, the attribute, the text color. As we saw before, the text composable has this parameter color to specify what we do. And we can get the colors from the material theme. So we can do material theme, colors, and we don't have the accent per se, but we can use the primary variant in our material theme in Compose. Text style, so XML attribute, we can use the font weight instead in Compose. So here we're going to use font weight bold. And that's it. That's going to be pretty much the watering needs, the header. And now let's move on to the every X days, which is going to be the text view below that one. Cool. So as we can see, center horizontal, we've already done that. That's specified in the column. And then we can also see that it has the same margin, the start and the end. And just to avoid duplication, we're going to remove it from the text composable, from the one above, and we are going to add it to the column. Because, you know, if the modifier is going to be applied to the column in that sense, it's going to be applied to both children. So here we can remove this. Let's do a little bit of cleanup. Recap. As a recap, we are passing the modifier, the padding on the sides to the column, and then the padding top is only going to be here in the text and the first text composable. Okay, what else here? Both of this is done, and now the only thing is now it's setting the text to the second text composable, and the text is set here in this watering text. And watering text, let's search for that in the project. What is that? Okay, so we can see that it's a binding adapter. This is one of the features of data binding. It's taking a step view, a text view, sorry, so it can be applied, this binding adapter can be applied to the text view. And what it's doing is that given a watering interval, it's gonna call this getQuantityString function from the resources. And in there, depending on the integer value, it's gonna have one string or the other on the screen, depending on the plurals. So basically, what we need to do is pretty much copy this behavior from the binding adapter and have the same in Compose. So let me copy this. and put that here above every X days. So watering interval is actually something that comes from the plant, and that's something that we can pass as a parameter here in the plant watering. So just to come here where it's called, we can say that the watering interval is going to come from the plant. So we can call plant watering, and now it's like, how do we get the resources? Do we have to pass them as a parameter as well, the same way as we are doing with watering interval? Well, the thing is that in Compose, there is a way to implicitly pass dependencies to composable functions using something called composition locals. You can read more about it in our docs, but we've already been using them. To access colors or typography from the material theme, we didn't have to declare it explicitly as a parameter. It was already available to us. And that's because material theme uses a composition local under the hood. And there are some Android-specific classes, such as the context or configuration, that are also available. So to get the context of our host view, we can use the local context composition local. So in here, in our composable function, we can say local context. We can access its current value, and from it, we can access the resources. So we don't need to pass this explicitly as a parameter. And that's it. Like implicitly, the local context is going to be available to us. I'm going to refresh the preview. And the local context is going to be obtained from the context of the compose view, which in this case is going to be that of the fragment. So the preview is refreshing, and now we can see that we can see what it needs. And I think what we need here is to try to fill the max width. Filling the max width is try to occupy as much space as possible. And then we should have it completely centered on the screen. Cool. There we
Perfect. Go. Look at that. Cool. So far we've looked at how we can embed Compose within views, but sometimes you actually want to do it the exact opposite. Perhaps you have a custom view that you've developed that you're not quite ready to convert to Compose just yet, or perhaps you're just displaying a view that you don't own, something like a web view or a map view, or perhaps displaying an ad. Now, Compose offers APIs to do just this. We can use the Android View Composable. Now, in our app, we want to display some text which is stored as HTML. Compose doesn't currently have APIs to display HTML markup, but we can use an Android view instead within Compose to display a text view from the view system, which does support this.
Mm-hmm. So we can actually open again the fragment plant detail, and this is the last text view that we need to migrate today. And just to give you an idea of what's happening, I can open the render adapter, render HTML, which is going to be another binding adapter. Here, this is what's happening currently in the view system. The text is set with this static call to HTML compat that it returns a span type. So the thing is that, as Nick was mentioning, Compose doesn't offer a composable function to display HTML markup, and the text composable doesn't accept the span type, just string. So what we need to do just to work around this is we are going to embed a text view inside Compose. So let's go here to our Compose code and create another composable function, and let's call it plant description, for example. And this is going to take the description that we assume it's going to be in HTML as a parameter. So here, let's call this from our main function. The description, it's going to come from the plant. And that's it. OK, so that's already set. So the API to embed view types inside Compose is called Android View. An Android View is a composable function. We can see the signature, and it takes a bunch of parameters. Factory, which is going to be a block that is going to create the view type, and then update. An update is going to be that callback or the block of code that is going to be executed after the layout is being inflated. So in our factory, what we need to do at this point, as you can see, it's provide us a context with which we can create the view type. And in our case, we want to create a text view. So we have text view, and we pass in the context. And in the update lambda, you can see it's giving us the text view. And the text view, we want to get it populated with this, with the text. So back here, so we can do text view, there we go, dot text, HTML compat from HTML. So pretty much we copy pasted what we have in there. So quickly we can see that the preview, if it refreshes, it's gonna show some HTML markup on the screen that coming from the fake plant. The fake plant already contains some HTML markup that we can see here. It's gonna be HTML, a couple of lines, and description. Cool, so that's working as we expect. And now we need to tweak what's happening. So just to finish off with the binding adapter, we can see that it's setting this movement method to be link movement method. And that's what's gonna analyze the HTML markup and recognize links that you can click on the screen, on your app. So here in the apply block, whenever we create the text view, we can set the movement method. So in our XML, we can see that we have here margin start top and end with margin small, and then we have a min height. But let's do the margin first. So in here, we are gonna use the padding. The top padding, it's gonna be small in this case. Yeah, it was small. And then we can duplicate it again and have the horizontal one. So we're gonna have margin small to the top and the sides. Cool. For the min height, which is gonna be this planted description value, we can use the height in modifier because for this, we can give it a minimum value. So we can gonna get the value again from diamonds, and we have it there. And that's pretty much it. I think we are ready. I think let's run the app. I mean, that's probably my bad. We haven't run the app since the Hello Compose. This is gonna be a little bit of a shame
because the preview's been so good. We haven't need to.
Yeah, exactly. That's the reason. Okay, so it's installing now, and we can come here and to the plant, and we can see in Avocado that pretty much is similar to here to our, actually the text in the description is a little bit small. We need to fix that. But you can see that if we click on Wikipedia, it's actually gonna open Chrome. This is what the movement method is doing. Okay, so what's happening with the text size? Okay, so it's this style from text appearance medium. But actually at this point, we are not styling Compose, we are just styling the text view that we can do with the text view compat, set text appearance. We can pass in the text view and then call our style and text appearance medium. Okay, so that's supposed to fix that really small text, and we can make it larger. Okay, so this is redeploying, and now we should see the larger text on the screen. And I think that's pretty much it. Probably the only thing that you saw is that theming doesn't work properly at the moment, but that's something we're going to cover in a sec.
We'll get to that.
Yeah, cool. The text is larger. Perfect.
Looking good. Okay, let's check in on the live stream. There's a couple of questions come in. One interesting one says that they think that XML readability might be more efficient than Compose, where the XML was exclusively responsible for the UI as opposed to the Compose way. Interesting question. Like perhaps in some cases that could be it. We're looking at some pretty simple views here, a couple of text views, but I've actually found that Compose can be actually really efficient for understanding it. And I think for a few reasons. Firstly, XML never really tells the whole story. I found that, you declare your views in XML, but then there's always some code that kind of like inflates that and hydrates it and actually adds the data to it. So I don't think it's really fair just comparing it just to the XML, because it's never just the XML on its own. It's always the combination of XML and some code behind it, which is updating or, hydrating the UI, whatever you want to call it. And I think that's where Compose shines, because you're not having to go through these mental hurdles of like context switching between them. It's all literally in one place. And you have the full power of Kotlin to kind of do control flow and, conditional state logic and statements. It's exceedingly efficient at that, I think. Another massive win, I think, for Compose for me is type safety. Like XML is kind of like loosely typed, and if you've ever tried to set attributes on a view and been frustrated that they don't necessarily apply, that just isn't a problem in Compose, because we can use the Kotlin APIs to build type safe APIs, so that you might have seen Manu setting some particular modifiers on different components. We use kind of scopes to make sure that those modifiers are only provided in places where they make sense. So it's actually a compile error to try and use a modifier which doesn't make sense on a particular element. So I think there's actually a lot of things going on in Compose. Sorry, Manu, yeah, go for it.
Yeah, just to add a little bit on top of that, it depends on the kind of Compose code that you write, because if you follow best practices, that actually is supposed to be not very hard to read. So you can see that, for example, here, one of the best practices is just to pass to composables what they need. And you can see that for plant name, plant watering, and plant description, we're not passing the whole plant. We're just passing the information that it requires. And for example, if you check plant name, you can see that it takes a string and that's it. And apart from that, everything is going to be UI styling. So it depends on how you structure your code. The good thing is because composable functions are reusable, that's if you follow best practices, you are going to see that reading Compose code is really easy. And it's actually, you can see here that you have a surface with a column, and inside the column you have 3 things. It's very easy to read, versus if you check out the commented out code here, you can see it's more difficult to see what's going on the screen. So it could be true in some cases, but in general, I think Compose wins in this case.
I think we could probably talk on this topic for the entire rest of the stream, so maybe we should leave it there. So continuing on with the code lab, so far we've converted some of you, but by default, a Compose UI is disposed when the view which holds it is detached from the window, but you can configure this behavior. So for example, the UI we've been converting is currently displayed within a fragment, but a fragment's view can actually remain visible for even while even when the view is detached. So for example, if you're running window transitions, the view may remain visible on screen even though it's being detached from it. Now, Compose lets us configure how you can set the lifetime of the composition if you need it to match a different life cycle than the default one of being between on attached and detached from the window. So Manu, how do we do that?
Yeah, so actually I'm going to show you why that happens. And if we go to the navigation graph, we can see that we are running transitions, enter and exit transitions on the plant detail fragment. So as you were saying, in the emulator, we cannot see that very well, but you can see that we have an enter transition and then an exit transition. And the default value, the default behavior of Compose, as you were saying, is that the composition is going to be disposed when the window is being detached from the Compose view. And in this case, while running the transition, while the transition is running, the window is detached. But you can see the fragment still visible on the screen and the transition happening. And that could happen, like the emulator is very slow and we cannot see that in action, but probably with a real device we could see, is that whenever the transition is happening, because the composition it's removed from memory, you're going to see an empty screen. You're going to see the Compose view being blank because the composition was removed. And to avoid that, what we need to do is hook the life cycle of the composition with that one of the fragment view. And we have APIs to do so. And the API, it's in the Compose view itself. So we can say Compose view, and it's the set view composition strategy. So inside here, we can see the different options that we have. Say view composition strategy, and then we have the dispose on detached from window. This is the default one. This is the one that we don't want for fragments, for dialog fragments, or for example, Compose views that are going to be items in a recycle view. The alternative is the dispose on view tree lifecycle destroyed, and this is one that we can use in our fragment, which is going to follow the lifecycle of the view tree. And then the other option is going to be the dispose on lifecycle destroyed, which takes a lifecycle or a lifecycle owner. So we could use the view lifecycle owner of the fragment to match what we are expecting for the composition to follow the fragment view lifecycle. but sometimes you don't know which lifecycle owner to use or which lifecycle to use. So it is safer if you use the dispose on view tree lifecycle destroyed. This option is going to automatically give you the right behavior. The other one is if you want to have more customization, if you want to really nail it and have some other or different, behaviors that you want to have.
Or it's an interface, right? So you can write your own composition strategy as well.
Exactly.
Cool. Any live questions? No more coming in just yet. So yeah, remember, feel free to put your questions on the chat. Okay, so we've migrated some of our UI to Compose, but you might have noticed that it isn't quite following our app's theme. Some elements were purple that I noticed. They're not following the app's green theme. Now that's because so far we've just been using the default material theme. We haven't set up any theming information in Compose itself. Now we could do this, but this would actually duplicate the source of truth, leading to having to have two places to maintain our styling information. Instead, what we're going to do is something quite useful in this kind of hybrid application situation is we're going to use a library we've created called the Material Theme Adapter. And what this does is it converts an XML theme into a Compose theme. So this is great for the hybrid situation, as it means you have this single source of truth. One thing to note is it's a one-way bridge, really. It can basically read the theming information present at the current context in the view tree and turn that into a Compose theme. It won't go the other way. So if you were to put any Android views inside your Compose hierarchy, it wouldn't go the other way. The reason is that the XML theming system is created at compile time. You can't create them dynamically, so the library isn't able to create these themes at runtime. But we can do it for you the other way because Compose lets you do dynamic theming at runtime. So we utilize that in order to read the current theme information from XML and turn it into Compose theming.
Yeah, cool. So let's do that. So if we take a look at the build.gradle file, the library that Nick was mentioning is this one, the Compose theme adapter. You can find it here. And the idea is here is we need to replace all instances of material theme for MDC theme. And MDC theme, it's actually what's gonna read all that. So let's quickly go. We are using the material theme in there and in our previews. So while the project is compiling and all that, MDC theme, it's gonna read the colors, typography, and everything from the current context. And that's what's gonna be displaying, and it's the theme that is gonna be created in Compose. And here we can see that it's gonna read the colors, for example, from styles.xml. So here we have the defined all our colors, and these are the ones that it's gonna be using. So we can see, like for example, here in our preview, it already updated it with the green color that we were expecting.
That's better.
Yeah, definitely. And something that we can do is that it doesn't only read light themes, it also works for dark themes. So we can actually have the preview to do the dark mode. And that we can do that with configuration, UI mode, night, yes. And now we can see we're going to create a duplicate preview here with the same pretty much function. And you can see that it also works. MDC theme also works for dark theme as opposed to light theme.
If you didn't catch that was one of my favorite features of the preview is that you can duplicate the preview annotation and have multiple previews. So for this one preview function, it's going to stamp out multiple previews in the preview pane, which is pretty cool. So you can actually, work on light or dark or font scaled versions of the application simultaneously.
Yeah, it's pretty cool. And another thing is that if you tap on the preview functionality, it actually will swap between them. For example, here to the plant name preview. So that's pretty neat. You don't need to scroll all the way to the previews.
Well, that was easy, switching our theming over. And the last step in the code lab we want to take a look at is testing. So after we've migrated parts of the plant detail screens to Compose, well, you want to make sure that we haven't broken anything. So we want to make sure our tests still pass. So the app currently has UI tests written using Espresso. We can update these to use Jetpack Compose's testing APIs instead. Now, Compose provides its own testing API and a testing rule for which allows us to host Compose content and then have some finders to find items within it and run assertions against these elements. So how does this look like, Manu?
Cool. So we can close this one. So the plant detail fragment, we can see that it's going to have its counterpart test class. So here we have the plant title fragment test, and let's run it and see what's happening after the migration. Just to give you a tour through the test class, it's going to have an activity scenario rule. It's going to have a before method that before every test is going to jump to the plant detail fragment using navigation. And then it's going to have a test to check that the plant name is visible on the screen, and another test to check that the share intent is fired, because you have the share intent, and then it's going to open the share sheet and all that. So tests are running, but the test plan name failed. And that's because the test plan name is using Espresso APIs, but now we convert it from the text view to Compose. So instead of Espresso, we need to assert for the name using the Compose testing APIs instead. And the API that we need to use for this hybrid screen, it's going to be the create Android compose rule. And that one, let me close the monitor for a second. It's gonna take the activity as well, here the garden activity. And this API, it's a wrapper on top of the activity test rule that is gonna allow you to test compose code as well. So instead of activity test rule, we can call it a compose rule. And here we were using the activity test rule to get into the activity. But the compose rule also allows you to get a hold of this one, of the activity rule. So nothing changes here. So we're saying like activity rule is contained inside this compose rule. Cool. So now we need to migrate this test from Espresso APIs to Compose testing APIs. And we have a bunch of documentation about testing in Compose. We have talks, we have code labs, we have documentation. We have also a cheat sheet with information about different assertions, how to search for things on the screen. So I recommend you to check out the docs. And here we are going to practically say, okay, on node with text, we want to find the apple as we had before. And then the assertion is assert is displayed. And that's pretty much it. This is Compose testing APIs in action. You can see that it has a similar syntax to Espresso, but a little bit shorter. So now we can run our tests again and see what happens. So you can see that this is running at the moment. You can see that test plan name is using Compose testing APIs. But also we have the test sharing text intent test that is using Espresso APIs. And not only that, you can see that the test plan name passed and the other test has also passed. And in the same class, you can have the functions using Espresso, functions using Compose testing APIs, but also you can have both of them, Espresso APIs and Compose testing APIs, working together on the same test. And that's because Espresso has an idling resource to wait for Compose to be idle. So you can mix and match both of them, and they can interoperate together perfectly. With that, I think we migrated the screen to Compose. Part of the screen, at least.
Perfect. Questions coming in on the live chat saying, is it possible to write a test for a single composable function rather than for the whole fragment or activity? Yeah, very much so. In fact, I think that's something that Compose actually makes a lot easier to kind of decompose your tests and actually have smaller units under test. In fact, actually, it's like one of my favorite things about the preview and the stateless composables we talked about previously is that they kind of actually make your composables much easier to test. Like the idea of a stateless composable, not only is it easier to preview in that, it makes its dependencies exceedingly clear, exactly what it requires, and a bit like dependency injection, rather than ever reaching out, it makes you pass them into it. This actually makes a lot of your composable functions much easier to test, and that you can pass in fake dependencies and test them. Another favorite thing, I'm quite a fan of the testing APIs, is it actually also makes it easy to do some kind of screenshot testing as well. You've got to do a bit of legwork for you. We've seen some frameworks being built up about this, but you can actually also capture screenshots or bitmaps of the unit and have that run a comparison against a golden, for example, in order to catch any regressions on those single items. Anything you want to add to that, Manu?
No, all good. That was pretty clear. Thank
Yeah.
you.
Yeah, it's actually something that we very much enjoyed when we were developing Compose. In fact, we have a lot of tests of all of the individual components that we create, and we've caught regressions and bugs and things by running these regression suite against our entire UI library. So yeah, big fan of that. Cool. I think that's it from the live question. So congratulations, we've worked our way through the migrating to Jetpack Compose code lab. So in which, like, just looking back, we covered how to incrementally migrate views, a view-based app, to start using Jetpack Compose. Like we said, you don't have to throw away your existing app. You can go piece by piece at your own pace and migrate just the views you want to use. We showed how Android views and Compose can interoperate, how views can host composables and vice versa, how composables can host views, and how you can interoperate using the resources system and so on. And then we also showed how to theme and how to test a hybrid application. But there's so much more that you can do. Isn't that right, Manu?
Yeah, so in this code lab, we migrated part of an existing screen to Compose. But if you check out the Compose branch of the original Sunflower GitHub repo, you can see that we have the full screen migrated to Compose. And you can see the image is going to be loaded with Compose. And we have animations to simulate that collapsing toolbar behavior, and much more things than that. And also we have the Compose pathway, where you can find a lot of information, more code labs videos about Compose in general, just to learn other topics. But specifically about migration, we have a pretty comprehensive set of guides in our developer.android.com page, where here you can see adopting Compose in your app. You can see the table of content, but later down the page, you can see that you have pages for how to add Compose to your application, the different dependencies. Also a page for interoperability APIs. So today we've seen Compose View, Android View, dimension resources and all that, but there are much more that you can check out. And also some tips and tricks of how to interoperate and how to have Compose, or how to add Compose to your existing architecture and existing UI. So previously I mentioned, how to have Compose as the item of your recycle build, and you can find all of that and more here in this documentation.
So thanks a lot for coding along with us, and have a great Android Dev Summit. Bye from us.
Thank you. Bye.
Hello everyone, my name is Edith Bilgen. I'm one of the engineers on the Android Toolkit and Jetpack team, and today we're going to be talking about what's new in Room. The last time we talked about Room was at 2.2, at which point we were already supporting so many features. But then all of those features weren't enough, and you still thought that there was still room for improvements. So here's what we've been up to since. First up, we have auto migrations, a brand new feature that's bound to make migrations easy. So let's do a quick recap before we barge into the room. What is a migration? A database migration allows you to update your database schema with any changes between versions while avoiding data loss. During a migration, Room will check and validate the updated schema. The schema can also be exported if the user sets a flag in the database definition. Before 2.4, you had to implement a manual migration class in which you would write and execute all the SQL statements needed to migrate between versions of your database. This meant that you would risk ending up implementing a migrate function involving a lot of long and complex SQL queries, increasing the risk for any errors. Let's walk through an example of this scenario. Say you have a database with two tables, artist and track. Let's say you would like to rename the table track to song. If you were to make this change using a manual migration, this is how that would work. You can see here that you will have to manually write and execute the statement to perform this change. However, with auto migrations, you can handle this change by simply defining an auto migration in your database definition and providing the exported schemas of the two versions. The auto migration API will handle the rest by generating and implementing the migrate function for you, complete with writing and executing all the necessary SQL statements. Now, let's go one step further and say we want to change one of the fields in the artist table, renaming singer name to artist name. While this may seem like something trivial, SQLite doesn't have an API for this, so we will need to go through the 12-step generalized alter table procedure. Using manual migrations, this would mean that you would have to manually write and execute all the SQL statements associated with the 12 steps. So here's how that would go. You would take the table you want to perform the change on. You would create a table that has the structure you want after the change has been made. As you can see here, the singer name column has been renamed to artist name. You would then insert the data from the old table to the new one to prevent any data loss. You would drop the old table, and you would lastly rename the new table to the original name of the table, which was artist, followed by a foreign key check. Looking at this in terms of code, using a manual migration for straightforward cases like this, where there's literally just one change done between versions, can be very verbose and error-prone. We definitely don't want to write all that, so let's use auto migrations. In the same example of a column rename, Room can't handle this out of the box. The reason for this is because of how auto migrations are generated under the hood. Room goes through the schemas of the two versions of the database, making comparisons to detect changes between them. In the case where a column or a table has been renamed, Room cannot clarify what changes occurred. Has it been deleted and a new one added, or has it been renamed? And the same problem applies for a deletion of a column or a table. In these ambiguous cases, Room needs a bit of help from you. More precisely, you need to define an auto migration spec. The auto migration spec is an interface for defining auto migration specifications, clarifying these ambiguous scenarios. This is done by annotating the spec with the relevant change annotations. So here, in this case, we have a renamed column annotation where we provide the table name, the original name of the column, and the updated name. Like this, the code is cleaner and easier to read and understand. As a bonus, if you have any additional tasks to execute after the migration has been completed, you can use the onPostMigrate function of the auto migration spec to run them. When you've finished implementing your auto migration spec, you will need to provide it to the database definition and define an auto migration. Now, once again, with the two schemas of the versions you want to migrate between provided, the auto migration API will handle the rest by generating and implementing the migrate function for you. Going back to the ambiguous change scenarios that require user input, these are all the available annotations. Even more, if you have multiple changes that require user input within the same migration, you can use repeatable annotations to provide the needed clarifications. All other changes will be handled out of the box without any input needed. Let's say you've started using auto migrations in your implementations, and you want to test that they're working properly. Well, good news! To test auto migrations, you can actually use the existing Migration Test Helper API. No change needed. Migration Test Helper will automatically run and validate all auto migrations, and no input will be needed from you. Under the hood, if auto migrations are present, they will be automatically added to the list of migrations to be run and validated. It is important to note that user-provided migrations are of higher priority, meaning that if you were to define an auto migration going between two versions that already had a custom migration defined, then the custom migration will be preferred over the auto migration. Next up, we have another big feature we have made room for: relational query methods. Let's say we have the same database from before with the same tables, which are now artist and song. And we want to get a collection that is a mapping of artists to songs. Looking at this with some example data in our tables, this would mean that Purple Lloyd would get matched with their hit songs, such as Another Tile in the Ceiling or The Great Pig in the Sky, and ABCD would get matched with their songs, Back in White and Highway to Heaven. If we're using relation and embedded, this is how the mapping would work. As you can see here, we create a brand new data class, Artists and Songs, where an artist is related to a list of songs. In fact, if we were to represent other relationships, we would need to create additional data classes to represent them, which can easily raise verbosity problems. Relation is meant to be used for simple cases where you would only have a few straightforward relationships in your database. Since in relation there's no filtering, sorting, grouping, or composed keys, you're limited in the relationship result, but it is a quick and easy way to get the job done for simpler tasks. In order to support these missing features, we didn't expand on relation because it would involve complicating the annotation and move users away from SQL. Room wants you to embrace SQL to its full potential, as it is very powerful. So let's look at how Room solves this problem with a brand new feature. To represent the same relationship shown previously between artists and their songs, we can now write a simple DAO method with a return type of a map. You only need to provide the query and the return type. Room will take care of the rest. Under the hood, what Room will do is find artist and song in the cursor and put them in the key and value. In this case, we have a one-to-many mapping where an individual artist is mapped to a collection of their songs. You can also have a one-to-one mapping like so. You can actually have a lot of flexibility in what you can use within the mapping. This is possible with the magic of the map info annotation. Map info is a helper API for user input in terms of clarifications, similar to the auto migration change annotations we talked about. It allows you to clarify exactly what you would like to do with the information returned in the cursor from a query. With the map info annotation, you can specify which column you want to use for the key and value mappings of your queries in the output data structure. It is important to note that the type being used for the key must implement equals and hash code functions, as this is crucial for the mapping process. Here's an example in which the artist name has been used as the key. Here's another example in which an artist is mapped to a list of their song names. And lastly, here's an example where an artist name is mapped to a list of their song names. The map info annotation gives you the flexibility to use specific columns instead of the entire data class for a more customized mapping. Another added benefit of relational query methods is that now we can support more data operations. Here's an example of grouping that is now seamlessly possible with this new feature. And here's an example of filtering that is now possible. Lastly, it's important to note that multi-map is a core return type and can be wrapped with the various observable types that are already supported by Room. So relational query methods allow you to easily define as many relations as you want in your database. Wow, that was a lot of big news, but we have room for more features. Here's a lightning round of some of the smaller cool features that we've added to Room. First up, enum type converters. Room will now default to using an enum to string and vice versa type converter if none is provided. If a type converter for an enum already exists, Room will prioritize using it over the default one. Query callbacks. Sometimes you want to log queries to see what's going on in your database. We added callbacks to the Room database's builder method, so when the database is running queries, it'll get logged. We have also extended some of our API support. Room now supports native paging 3.0 APIs and removes the previous workaround. Important to note that you will now need to depend on a new artifact called Room paging. We've also added support for RxJava 3 and note that you will now need to depend on a new artifact, Room RxJava 3. Last up, Kotlin symbol processing, for short KSP. Room 2.4 now includes support for KSP, a native replacement for CAPT that runs annotation processors as a part of Kotlin compilation. Moving to KSP is very simple. Just remove the Kotlin CAPT plugin, unless you have other annotation processors using CAPT, and replace it with the KSP plugin. Similarly, in your dependencies, add Room to the KSP configuration instead of CAPT, and you're done. So, why switch to KSP? Well, KSP provides up to 2 times faster compilation for Room, speeding up your builds and saving valuable development time. As KSP directly reads Kotlin code, Room has a much better understanding about the Kotlin code like nullability and generates code accordingly, preventing null pointer exceptions at runtime and much more. As KSP becomes stable, we will expand Room's Kotlin support for long-awaited features like value classes support and generating Kotlin code. Auto migrations, relational query methods, KSP. This was a lot. We hope you're just as excited as we are about all of these Room renovations. Do check them out and start using them in your apps. Thanks for watching.
How's it? My name is Nick Rout, and I'm an Android Developer Relations Engineer. Today, I'm excited to talk about how to implement Material U in Jetpack Compose. Material U is the next evolution of material design. It's a radical new design vision focused on delivering experiences that are personal for every style, accessible for every need, and adaptive for every screen. Jetpack Compose is Android's new, modern, native UI toolkit to help you build better apps faster. You may be familiar with the existing Compose material library. It's based on the Material Design 2 specification and includes features like material theming, material components, and dark theme. We're excited to announce the launch of the new Compose Material 3 Jetpack library, available in alpha today. It's based on the Material Design 3 specification, with updated theming and components, and includes Material You personalization features like dynamic color, and designed to be cohesive with the new Android 12 visual style and system UI. You can begin by adding the new androidx.compose.material3 dependency to your build.gradle files. To illustrate how to adopt Material Design 3 and Material You, we'll be using JetChat. JetChat is a sample chat app built with Jetpack Compose and currently uses theming and components from Material Design 2. We'll be implementing this beautiful update to JetChat provided by our designer using the Compose Material 3 library. It includes a broader range of tonal colors, fresh updates to components, and even incorporates dynamic color to make it more personalized. Let's start with material theming. The existing material theme composable is an implementation of Material Design 2. It allows for application-wide theming of Material 2 components by adjusting colors, typography, and shape systems. We've introduced a new version of Material Theme for Material Design 3. Material 3 components can be themed by adjusting color scheme and typography systems, with updates to shapes coming soon. Firstly, let's take a look at color schemes. Material Design 3 separates colors into named color slots, such as primary, background, and error, which are used by Material 3 components. Together, these slots form a color scheme. Some of the slots remain from Material Design 2, while others have been newly introduced to expand the overall palette. They all feature beautiful, new default baseline colors for both light and dark themes. These colors are drawn from a set of tonal palettes. For example, let's take a look at the primary color slots. The color values used by the slots come from the different tones in the primary tonal palette, selected for light and dark themes to meet accessibility requirements. Compose models this with a new color scheme class. Its parameters are named after the slots in the Material Design 3 color scheme. Use the light color scheme function to create an instance of color scheme with light baseline values, overriding the defaults with custom colors. Or use dark color scheme for dark baseline default values. Use the isSystemInDarkTheme utility function to switch between light and dark color schemes, depending on the system setting. Pass the color scheme as a parameter to Material Theme. To learn more about custom color schemes, dynamic color, and new tools for your designer and developer workflows, check out the Material You Applying Dynamic Color in Your Brand session. Now, let's take a look at the JetChat color scheme. JetChat's color scheme was generated using the new Material Theme Builder tool. We use JetChat's blue and yellow brand colors as the primary, secondary, and tertiary source colors. The resulting Material 3 color scheme fits the JetChat brand. And we get colors for both light and dark themes. These branded colors are drawn from the custom set of tonal palettes generated by the Material Theme Builder tool. For example, here's the primary blue JetChat tonal palette and the matching primary slots from the color scheme. To implement the JetChat color scheme, start by declaring these colors with the color class. The Material Theme Builder tool can also export this generated code for you. Next, declare a light JetChat color scheme using the relevant color values, and a dark JetChat color scheme. We've created a new composable function for our JetChat theme. It accepts a parameter for dark theme as well as a slot for app content. Use the dark theme parameter to switch between the light and dark JetChat color schemes. Pass the color scheme value and the content to the inner Material Theme composable. This allows us to wrap our JetChat content and provide theming values to our app. Let's take a look at the JetChat conversation screen. Parts of the UI use different color slots from our color scheme. For example, the message avatar uses either a primary or tertiary border, depending on the user. It accesses color theming values with the Material Theme.colorScheme notation. Next, let's take a look at dynamic color. Dynamic color is the key part of Material You, in which an algorithm derives custom colors from a user's wallpaper to be applied to their apps and system UI. This is used as the starting point to generate a complete light and dark color scheme. Dynamic color is available on Android 12 and above. To implement a dynamic color scheme in Compose, start by checking the build version SDK. If dynamic color is available, we can set up a dynamic color scheme. If not, we can fall back to using a light or dark color scheme as before. Use the dynamic light color scheme function to create an instance of color scheme with light dynamic values, or use dynamic dark color scheme for dark dynamic values. Pass in a context so that dynamic color resources can be fetched from the Android system. Let's adapt the JetChat color scheme for dynamic color. At the moment, JetChat uses the branded blue color scheme at all times. However, we'd like to add support for dynamic color schemes based on the wallpaper, adapting to the user's personalization. In this case, tonal palettes are internally generated from colors in the wallpaper. A dynamic color scheme is derived from these tonal palettes, and we get colors for both light and dark themes. To implement this in JetChat, let's start by updating our theme by adding a new parameter for dynamic color. Use the dynamic color parameter to set up a dynamic color scheme, or fall back to the branded blue color scheme if it's not available. As before, pass the color scheme value and the content to the inner material theme composable. The JetChat UI now automatically adapts to the user's wallpaper on Android 12 and above, giving us a beautiful, branded experience for both light and dark themes. Now that we've covered color schemes, let's take a look at typography. Material Design 3 has a new type scale, including text styles that have been adapted from Material Design 2. The naming and grouping have been simplified to display, headline, title, body, and label, with large, medium, and small sizes for each. Compose models this with a new typography class. Its parameters are named after the styles in the Material Design 3 type scale. Create an instance of typography with Roboto baseline values, overriding the defaults with custom text styles. Pass the typography as a parameter to Material Theme. Now, let's take a look at JetChat's typography. The designer has given us a new branded type scale using custom fonts, Montserrat and Carla. Start by declaring these fonts with the font family class. These will hold instances of the font class, which can be constructed with a font resource ID and a weight. Declare the JetChat type scale using the typography class, and override each of the text styles using the text style class, our fonts, and other typography values like font size and weight. Pass the typography as a parameter to Material Theme. Let's take a look at the JetChat conversation screen. Parts of the UI use different text styles from our JetChat type scale. For example, the message, author, and timestamp use the title medium and label small styles. They access type theming values with the Material Theme.typography notation. Now that we've covered theming in Material 3, let's take a look at another update to a key aspect of material design, elevation. Broadly speaking, elevation has changed from using shadows in Material 2 to tonal color overlays in Material 3. This is a new way to distinguish containers and surfaces from each other. Increasing tonal elevation uses a more prominent tone. Elevation overlays were a part of dark theme in Material 2, which have also changed to tonal color overlays in Material 3. The existing surface composable is an implementation of the Material Design 2 elevation system. It accepts an elevation parameter and handles rendering shadows and overlays in dark theme. We've introduced a new version of Surface for Material Design 3. It accepts a tonal elevation parameter and handles rendering tonal color overlays in both light and dark theme. Surfaces are the backing composable behind most material components. So let's take a look at the updates introduced in Compose Material 3. Material 3 includes a variety of updates to components like buttons, app bars, dialogues, fabs, and navigation components. These updates make use of the new Material 3 theming values and include fresh new updates to each component specification. For example, let's take a look at bottom navigation in Material 2. It aligns with the Material Design 2 specification and accepts parameters like background color and elevation. In Material 3, the component has been renamed to Navigation Bar. It aligns with the Material Design 3 specification, and the parameters have changed to container color and tonal elevation to more accurately reflect their purpose. There are a variety of updates to components in Compose Material 3. To get a full overview of all the components and how to implement them, we've updated the Compose Material Catalog app with a new Material 3 section. Check out the source code on AOSP and download the app on Google Play. Let's take a look at one of JetChat's components. On the profile screen, we have an extended fab to compose a message. This has been updated from the Material 2 to the Material 3 version. Here's a simplified implementation in Material 2, showing an extended floating action button composable, inner icon and text composables, and a custom primary background color. Here's what we did to update it for Material 3. The imports for the composables have changed to Material 3. We're using the renamed container color parameter and the tertiary color from our Material 3 color scheme instead. Some aspects of Material U come from the new Android 12 Visual Style and System UI. Two key areas where there are changes are Ripple and Overscroll. Ripple now uses a subtle sparkle to illuminate surfaces when pressed. Overscroll now uses a stretch effect at the edge of scrolling containers. No additional work is required to implement these changes. Stretch Overscroll is on by default in scrolling container composables in Compose Foundation 1.1 and above. Sparkle Ripple is available on Android 12 for all material components. Interoperability with Android views is an important part of developing apps with Compose, and we've made some updates to support this for Material 3. MDC Android Compose Theme Adapter is a library that enables reuse of material components for Android XML themes for theming in Jetpack Compose. The existing MDC theme composable is compatible with Material 2 XML themes. We've introduced a new MDC3 theme composable, which is compatible with Material 3 XML themes. It's a great time to try out Compose Material 3 in your Android apps, and we've prepared a collection of resources to assist you on your journey. There's a new API reference documentation for Compose Material 3, and a new empty Compose activity template in Android Studio, featuring Material 3 updates. There's also updates to the Theming in Compose guide, and, as we've seen, the JetChat sample and Compose Material Catalog apps, and the MDC Android Compose Theme Adapter interoperability library. Hope you enjoyed it. Thanks and take care.
Okay, welcome everyone to the Jetpack Compose with Material U panel at Android Dev Summit 2021. I'm your host for this session. My name is Adam. I'm a lead Android engineer at Cover and GDE for Android. We've got a live chat running, so if you haven't already asked a question on Twitter, please feel free to ask questions during the live panel, and we'll do our best to answer as many of those as we can. And we've got a great lineup today with a wealth of knowledge on Compose and Material U. So let's go ahead and introduce them. Connie, you want to start?
Hello, everyone. My name is Connie Shi. I am an Android developer on the Material Android team. Most recently, I worked on the Compose Material library modules. Over to Leland.
Hi, I'm Leland Richardson. I'm a software engineer working on Jetpack Compose. Over to Claire.
I'm Tara. I'm an engineering manager on the Compose team.
And hey, I'm Nick. I'm an Android developer relations engineer focusing on Jetpack Compose and material design.
Awesome. Well, thank you all for being here. And let's launch into our first question. This is a question that I've seen coming up quite a lot regarding Material U. So how do we design for pre-Android 12 devices going forwards? Do we attempt to port the Material U design to older platforms, or do we downgrade to the older Material theming to fit in better? What's the kind of best practice here?
I think I can probably take a shot at this. So here, you need to keep a few things in mind. So you'll need to migrate to a Material Design 3 theme to take advantage of dynamic color on Android 12 plus devices. So you need to keep that in mind. We then also recommend that you create a custom theme to be applied to your app when dynamic color isn't available. And we've actually made a new Material Theme Builder tool to help you with this process. And we've also got a couple talks out at ADS, which should also give you lots of great info on this as well.
Cool. Yeah. So I caught up with the talk regarding sort of integrating the Material U into your branded colors earlier. It's got a ton of great information in it. I think that the tool that's been released as well that you mentioned is going to be super useful as well. So I definitely recommend everyone checks that stuff out. How easy is it to integrate Jetpack Compose into an existing application which uses view binding?
I can take this, I guess. The question is about view binding specifically, which I guess there's a few ways to interpret this question. So if you wanted to use view binding with Jetpack Compose, like on Jetpack Compose UI, that's not really something that you can do, because view binding is really made to sort of get rid of that find view by ID type call, which Compose really doesn't have. It's sort of architected differently. But if you wanted to use the two side by side and sort of migrate slowly over to Compose, while some of your UI is still using XML layouts and view binding, then that all works fine. And definitely that sort of incremental migration path is something that's been really important for us from the start for people wanting to adopt Compose.
Yeah, it's clear that it's been a really big focus for the team. I think if anyone is using data binding over view binding still, which I'm sure a lot of people are, there is also Compose interop as well. I think we've used it once or twice at Cover, and that, like the rest of the interop, seems to work pretty seamlessly. So that's an option for people as well.
Yeah, I know that in the past we've had some issues here and there around getting the data binding annotation processor to work with the Compose compiler plugin, just because there's some compiler stuff going on there. But my current understanding is that all of those things have been solved. So if you are having any sort of issues kind of related to that, then definitely file a bug.
Cool. Yeah, there's quite a few moving parts there. So great. There's a lot of cool support for making animations in Jetpack Compose. But does anyone have any recommendations for designers and developers to get aligned? So on this person asks, on the one hand, I don't want designers' creativity to be limited. On the other hand, I don't want to give designers false hope either. Has anyone got any kind of insights they can share on that aspect?
I can take a stab. We've we've resought animations with Compose. So Compose has a complete new set of animation APIs that are actually extremely powerful. So a lot of the things that were really hard to do before are actually quite easy to handle in Compose, which some we're still finishing how we. So the APIs we don't fully have there as stable are element transitions. That's something that we're still completely working on. It's not fully stable as far as I know. But otherwise, I have seen the community have done a lot of work trying to integrate Lottie with Compose, and I'm pretty sure that's working at the moment. So there are a lot of things that are possible, and I would challenge things that you thought were not possible with the view system may be possible now. So it's worth reopening that conversation. Does someone have more? Leland, maybe?
Yeah, I mean, definitely if there are sort of types of animations or something that you feel like aren't accomplishable with the current sort of set of APIs and primitives, then definitely like surface that with us. We're always interested to understand what kinds of things people want to do. And you know, our goal is to make APIs that are easy to use, but flexible enough to kind of encompass all of the use cases that people might dream up. You know, and as Claire mentions, there's kind of a lot of different things that you can do. You know, there is, you know, Lottie is supported now, which isn't something we did. You know, Lottie, the Lottie team built support for Compose. And there's a lot of cool new animation APIs coming out that I'm probably not the best person to talk to, but the big one that we're still not quite there yet, and you know might be in you know next release or something like that, is the shared element transitions, which is something that we really needed to kind of think about the fundamentals about how to accomplish such a thing correctly. And it really needed us to kind of rethink some of the ways that the runtime actually works. And so we've been working on some sort of new fundamental kind of APIs in the runtime that enable things like shared element transitions in a really cool way that I'm pretty excited about.
Great. That sounds super interesting. Awesome. That's something to look forward to. So some live questions coming in. So what is the best way to debug recomposition? How often is it happening? Is it too often? Should it? And what's causing that kind of problem? Leland, I suspect this is one for you as well.
Yeah, that's a great question, and one we're thinking a lot about. It's definitely a tooling problem that we want to work on, and we have some things that we're doing that we aren't really ready to release yet. At the moment, you know, when you're looking at something recomposing, there's really kind of one main thing that causes something to recompose, which is you know, a state mutation that happened to a state object that got read during composition or during another phase of compose. And sometimes that can kind of happen without you realizing. And so that's where this sort of tooling becomes very important. And, you know, right now, like we sort of direct people to use the tools that, you know, are and have been available to them, like, you know, just the normal Kotlin debugger and, you know, even sometimes using like Printline and you know, the Android logging system can be helpful. And so that's kind of my best recommendation at the moment, but with just sort of the sort of future looking thing that you know, promises this is something that we're definitely thinking a lot about, and we'll hopefully have some new tooling to make this easier for people.
Awesome. Do you think that this is something that people are maybe thinking a little bit too much about? I think we've had a lot of discussions within our team about recomposition and, you know, does this trigger it and does it not? Are people kind of overthinking this a little bit too much? Is a lot of this not something you have to worry about?
Yes and no. I mean, I think that if you have a performance issue and something is recomposing more than you expected, then, you know, very clearly that's something that you should care about. I've talked about this before, where there's kind of this interesting thing, which is something I'm not super happy about, which is that Compose can feel somewhat magical sometimes, and we don't really want it to feel magical or surprising. We just want it to feel intuitive and just sort of work. And sometimes there's like a really good simple mental model to understand okay, like what I kind of use as a guiding mental model is wherever I have a state read, if I just kind of travel up the code, the nearest composable function is going to be the thing that recomposes. In reality, that's not always the case, because there are a lot of different sort of micro optimizations that the compiler might be executing, and it really may end up being somewhat surprising what sort of more narrow or more broad scope ends up recomposing just as an optimization. But in general, you should be writing code where if you follow that earlier mental model, it should sort of work that way. Like the code's behavior should be the same. And that's sort of the point, is that mental model then ends up being a good sort of guide in terms of the behavior. But there are some times where if you really understand how the system works, then you can write things that are slightly more performant. I would just sort of guide people to sort of only worry about that once you know that performance is a problem in that particular situation.
I'd also add, I feel like the code that Leland writes is always going to do the right amount of recomposition, but most developers out there are not someone from the team. And it's part of the learning process, right? Like to me, if we can figure out how to properly tool composition debugging, it is a step towards what we've been trying to achieve with Compose, which is that it's easy to learn and it's really easy to ramp up, but it's always going to be part of that learning curve. I don't think anyone's ever going to write perfect code from scratch. And so it is a tool that we're aware is missing there to really help people learn.
Great.
Well,
Okay.
there's sort of this overarching principle that we've had from the get-go, which is that we want the sort of natural code that you write to be the best code. And we obviously can't do that all the time, but we don't want people to be bending over backwards to write something that is just slightly more performant. And if there's something that you think is a common pattern that is nice code but performs poorly, then maybe open up a bug or something to kind of identify this as a pattern that we might want to think more about or optimize.
Great. Awesome answers. Thank you. Thank you both. This person asks, we rely on motion layouts quite a lot, and I was wondering whether this would be available in Jetpack Compose or how one can migrate their motion layout.
I can take a stab at this. Motion layout is interesting because we kind of developed motion layout and Compose in parallel, and we reached a point where both products were kind of going in parallel tracks. We are looking at motion layout and Compose. The key is animations are really good in Compose out of the box, so I would really encourage people to try and build things. When you're starting from Compose, and Compose is the thing that you're trying to write, try to write Compose code with Compose animations. But you saw already we added support for constraint layout because it is something that developers asked us. Like you're used to constraint layout, you want to be able to have those capabilities. We add that, and similarly, we're looking at motion layout. But I don't think it's a giant gap that we're trying to fill with motion layout because animations are really powerful.
Yeah. I was going to say, I mean, it has parallels to constraint layout, where I think I think constraint layout and motion layout both kind of filled gaps that were in the view system, but Compose doesn't necessarily have these kinds of limitations. So for us personally, we don't reach for constraint layout very often in Compose. There are obviously use cases for it, but very similar, I think. Cool. So how do branding colors work with Material U? We have specific colors for our brand. Do these get overrun by Material U?
I could start answering this question, and I'm sure Nick has some inputs as well. So definitely understand your concern. We want to allow personalization based on a user's wallpaper colors, but also we want to be respectful and support developers who have very strong brand colors or other colors that they'd like to protect. So with respect to your particular question, no, they do not get overwritten by Material U. So when you use material theming from the Material 3 library, you can choose to use dynamic color, which is sort of a signature piece of Material U. If your user's device is on Android 12 and with the, color slots in our color scheme that you would like to map to your brand colors, you can explicitly specify those, and those will not be overridden by Material U. So basically, we encourage you to adopt Material 3 so that you can then try out, and whatever is comfortable for your brand and your product, you could, opt in at the pace of your choosing. So, yeah. Nick, do you have any other advice?
Yeah,
I'm
yeah,
sorry.
I'll add to this. So I think it ties into the question earlier in that in most cases you do need a fallback color scheme because dynamic color is actually only available on Android 12 and above. So it's a good idea to actually get going with a branded color scheme from the start as a fallback for that, but also just if you want to use that primarily in your app. And again, this is where that material theme builder tool can come in really handy, just because the color scheme class in the Material 3 library models the Material 3 color scheme, and it actually has around 26 parameters that model all of the color slots, which is quite a lot and gives you a lot of flexibility in your design. But in terms of like mapping your brand colors to those, it can be quite potentially overwhelming or just quite a lot at first. So that theme builder tool actually allows you to put in key brand colors, which then harmonize those and expand those that feels like it fits in with Material U, but still feels like your brand as well, which I think is a pretty good approach to take here.
Yeah, and since the theme builder, is there's a Figma plugin, right? Your designer could do that and provide you. I think the experts compose and Android XML code, so you don't have to do it by yourself.
Cool. Yeah, and from what I understand with that tool, there's scope for sort of extra colors if you have like quite a big brand palette. So it looks pretty flexible on that front, from what I understand. Cool, great. Cool. So a more slightly kind of architectural question. So should we have one scaffold per screen or one single scaffold outside of navigation? Pros and cons.
That's a good question because it's something the team is discussing internally now. We bit scaffold as a way of helping you build that material app, right? And it helps you put the fab and the bottom nav and the top up bar in the right place. It helps us figure out things like interactions between those components. But especially as we started exploring large screens, we started to hit kind of the limits of it because it was really hard to build certain things. We even saw in our JetNews samples, ended up having to nest two scaffolds to achieve what we wanted because some of these elements were per screen and some of these elements were for the entire app, and we ended up with this weird dichotomy. So the real honesty is we're starting to rethink how we approach that. Right now we only have one scaffold, and that's what's the public API. So you can follow the example, like for example, JetNews I know has two nested scaffolds, and that's how we solved it. It's not ideal, and we're looking into this, but for now, sadly, it is the answer.
Interesting. Hadn't caught that. I'll have to have a look at that a bit later. Great. So can you talk about the new elevation updates in Material 3? And this is something that's changed substantially, I think.
I guess Connie and I can take this one as well. Yeah. Well, I'll let Connie handle the implementation in the Material 3 library. She's very familiar with that. But just in general, there's a sort of expanded way to look at elevation in Material 3, where there is both shadow elevation, which you may be used to from Material Design 2 and everything that came before Material 3, but to a lesser extent. Primarily now, elevation, or I would more like to think of it as a way to like separate different containers of content in your app, is done with this tonal variation of colors. So basically you would increase the elevation to increase the tone of that container, which sort of increases its prominence. And you'll see this around the Android 12 system UI and just generally speaking in Material U and Material 3 apps. But yeah, Connie, do you have any thoughts?
Sure. I agree with everything Nick said. Just to add that it is not an entirely new concept. We sort of expanded on something that we already did in the previous version of Material. You might be familiar with elevation overlays in dark themes. So we took them and expanded it. So now it's an effect that is applied in both light and dark theme, as well as in your dynamic light or dark themes. So we think that it creates an interesting visual effect, and it softens the it's an interesting visual effect and softens the transitions between interactive elements. So you might notice a very prominent example is in our top-up bar, as you lift, the color fill changes, and we think that's kind of a delightful effect. Also, as Nick mentioned before, the contrast is for accessibility benefits, but we think it's kind of a delightful visual feedback for everyone. In terms of implementation, you'll be familiar that it is part of the Surface composable. There is 2 different options for you to configure: the tonal elevation and also the previously available shadow elevation. But definitely, if you would like to learn more, there is a section on the m3.material.io site under, I believe, color systems. So thanks for the question.
Great. This is something that we were discussing at Joy-Con London today, actually. So are there any APIs available for screenshot testing in Jetpack Compose?
That's a good question. We actually have internal screenshot testing. I think the key here, we're working with the AndroidX test team. So there's an AndroidX test library, and we're working with them to figure out what we should do. The key is screenshot testing tends to be very tied to what your CI/CD is. And so it's really hard for us to right now put those APIs in and make them fully useful without having a full story there. So it's something that is in the works, but we're not ready to share in any way.
Cool. Okay. There are a few community options out there as well at the moment. I think there's a library called Snap, which has been doing Compose snapshot testing. I think it's built on top of a Facebook library. It's been around for a while. And I think the Cash App team, Paparazzi, supports snapshot testing. I don't believe they support Compose just yet, but I think it's on their roadmap as well. So there's a few options out there for people who want to investigate this kind of thing. It does seem to be something that is more popular now, presumably as people are migrating from one thing to the other. Lovely. So will there be something like Layout Manager in Compose in the near future?
I assume this is asking sort of in relation to lazy row and lazy column.
Presumably, yeah.
Yeah. I don't know for sure. I think... Yeah, Clara, go.
I can take this. We're currently, if you're following kind of tip of tree compose, we're currently in the works. We're trying to, so we built lazy column first, and we're now trying to extract the lazy bit of it so that we can build more layouts on top without having to rewrite a bunch of the performance optimizations that we've done inside. That's currently in the works. It did not make 1.1 as far as I know. So you can see it if you're in top of tree compose, or if you follow our alpha releases, you will start seeing some hints of these sort of things, but it's in the work. Yeah, not ready.
Nice. Very cool. How can we support keyboard with Jetpack Compose for both focus and accessibility?
So we've actually done a ton of work in that. That is one of the biggest things that is landing in 1.1 beta, which was released yesterday. We have done a lot of work on keyboard, mouse, and focus. So you should find that already built into the system. You can find the new focus APIs as well. So I'm not sure what else specific details this person's looking for, but check out the new changes in 1.1.
Great.
Yeah, I think it might be safe to say that if there's issues now, then you should sort of consider them as bugs, and we'd appreciate any help. If you're trying 1.1 and you're finding something doesn't work for your use case, then we're definitely interested in hearing that.
Okay, so that kind of support should be pretty well fleshed out and pretty final at this stage, effectively. Lovely, awesome, cool. So we have this is a question that I've seen some people asking a few times. So we use Kotlin files like color.kt to define the theme in Jetpack Compose. Do we still need themes.xml? Is it going to go anywhere?
Again, good question. Themes.xml still has a place as long as we still have, for example, you're going to be defining manifest colors, right? You will want your status bus color. Compose can't take care of everything right now. Compose is hosted within an activity. And so there is still a space for that, and a minimum requirement, at least, of some of the elements that kind of set up the scrim of an Android app, which we haven't got around to being able to integrate into Compose. On top of that, most apps are doing interop right now. So they will have an existing app. It has a lot of views, and it's starting to have Compose. And we've built an adapter. There's a material theme adapter that helps you move your themes from XML and kind of import those at runtime into Compose and be able to pipe those colors through. But it's not something we can do the other way around because the theming system in Android is built at compile time. So we can't take runtime generated colors from Compose and actually pipe them into views. So as long as you still have views in your app, you are going to have XML colors and XML themes as the source of truth, just because you will otherwise not be able to use things that you define and Compose from views, if that makes sense.
Cool. So to avoid the kind of duplication issue in that case, then, does it make sense for people to reference these XML colors and that kind of thing from Compose directly, or is that not something that you recommend?
I think as long as a color is used both from views and Compose, it makes sense to keep the source of truth in XML. And yes, reference those. We have APIs to reach out to all of the resources from Compose. So you can do color resource and pull that in. And I think as long as you have views, that is the recommended path.
Cool. Great. So along with the new Material 3 library and the new additional Android Studio tooling, what other best practices can you share to Android developers to help prepare their apps to use dynamic color with their brand's theme for Android 12?
Yeah, yeah, sure. Well, again, I'll say here that this is where the Material Theme Builder tool really shines. You can create custom color experiences. You can also visualize what a wallpaper would look like in the app as well. And yeah, I guess we've got a lot of resources as well that you can take a look at in terms of like when you should use a dynamic color scheme, when that's supported, when you should fall back to a branded one. But yeah, basically you can include your brand colors in that tool, and you can expand on that, as we've spoken about already, to increase the amount of colors in that palette. And yeah, again, we've got talks here, especially the material you're applying dynamic color in your brand one at ADS that I'd strongly recommend checking out.
Can I also add, we just released the first alpha of the library yesterday, so we're super open to feedback. If you start trying to implement all of these things in your app, please do file feedback on the team, because we would be really interested to see how it's working for you.
Yeah, that's a great point. That's a great thing to call out there. So what Material U styled components are currently available?
That's a great question. I'll start by saying that we introduced new updated baseline light and dark color schemes, as well as typography. Of that, we've updated a bunch of new components. Some highlights are, as I mentioned before, top up bar, which shows off that nice tonal surface elevation. But for a full list, you can check out, once again, m3.material.io. We think that it has a good coverage of the most common and also common components, and shows off the changes that were introduced in Material Design 3. But yeah, like Claire was saying, we're still in early days, actively developing and adding more updates with each release. So happy to hear feedback and make adjustments.
Awesome, great. Cool, and this half hour has gone by very quickly, so we're on our last question now. So is there anything that I should be aware of before trying to use Jetpack Compose to make an Android TV app?
It's a good question. Leland, I feel like this is in your territory. So let me start. We haven't actually worked on, we've been very focused on Compose for the phone for our 1.0. Now we're looking at large screens, and that's been the focus, kind of 1.1, and probably will be for the next release as well. And we haven't really tackled TV yet. You've seen where Compose is out as well. So we've been looking at some performance issues when you run Compose on a very small screen, because Where has been one of our focuses. But the interesting thing with TV is it's a very, very large screen with lots of pixels to render. So there's interesting things that I think we haven't looked at yet. We've started, one of the big things that define UI in TVs is the navigation, and you navigate with the D-pad usually with a remote control instead of the finger. We have done some work in that space, and we have enabled D-pad navigation. I don't think it's perfect yet. Like it's still working, that we haven't fully polished Leland, do you have more thoughts on like performance parts?
Yeah, I mean that pretty well covers it. I think when I think of the challenges that come with TV, it's really about D-pad support and then device performance profile. Like you have large screens and typically not so great hardware, and so it's a tough combination. And so definitely, it's something that we want Compose to work for, but there might be, with that particular sort of profile of device, there might be challenges that we're still working out. Let's see. I mean, also the SDK. So like some TVs might have much older SDKs, so you want to make sure. I mean, Compose supports 21 plus, but on some of the older SDKs, we're going to struggle a little bit more in terms of memory management and some graphics performance and things like that. So also watch out for that. You'd want to make sure, so sometimes TVs might not be, so they might not have like the Play Store and things like that. So you want to make sure if you do sort of build something for TVs, that we want to make sure that the app is being ahead of time compiled in a way that will leverage art and not interpret all the code. Basically, Compose ends up pushing your devices to where for initial runs, a lot more of your app is going to be interpreted if you're not careful. We have mitigation strategies around this that are currently in place, for things, like most phones and stuff, but I'm not sure if that's going to be fully working for TV. So these are all just things to think about and probably test before diving into TV, because we haven't spent as much time sort of optimizing this case yet.
Great. Awesome. Well, that's it for this panel. So thank you everyone for joining us, and I hope you've had a lot of great takeaways from this session. If you've got any more questions, feel free to reach out to everyone on Twitter. I think everyone here is pretty communicative on there, and hopefully we can point you in the right direction. Enjoy the rest of Android Dev Summit 2021.
Hi everyone, and welcome to our Compose for Wear OS Code-Along session. I'm Ksenia Shumelchik from the Android Developer Relations team, and today I'm joined by Jeremy.
Hello, I'm Jeremy Walker. I'm an engineer also on the Android Developer Relations team.
Earlier this year, we launched a major Wear OS platform release along with the updated Wear Material Design Guidelines. These guidelines are in line with the new material design language, and in future, we'll expect all apps to be compliant with new guidelines. To help you, we are bringing the best of Jetpack Compose to Wear OS. Compose for Wear OS not only simplifies UI development, but also introduces components that are already compliant with Wear material design out of the box, meaning that you can more easily follow the design guidelines and create beautiful apps with less code. During today's session, you will learn how to create composables specifically for Wear OS, so you can start writing your own apps right away. And now, over to Jeremy to tell us more what exactly we are going to build today.
Okay, great. Thanks, Ksenia. So you guys should already, or everyone should already have access to the code lab. It should be in the description in the live chat. If you don't, just open up search and search for Google Code Labs. It should be this one up here. If you click into that, you can just filter by category. There's a lot of good code labs there. And if you go down to Wear OS, you should see it right here, Wear OS Code Lab. So Ksenia did a great job talking to you why you should check out Compose, so I'm going to skip that. Let me cover what we're going to learn first. So we're going to talk about some similarities and differences between your previous experience with Compose and Wear OS. We're going to actually create some simple composables that work on Wear OS, then some Wear OS specific composables. After that, we'll close out with the Wear OS's version of both the lazy column and the scaffold. So this is what you'll build. It's pretty straightforward. It's going to be a list of Wear OS composables, and it's going to be wrapped in the scaffold. And then up top, you can see the scaffold will show the time with curved text. It'll add an indicator here for when you want to scroll. So we'll build all that out. Just a quick FYI on the prereqs. You do have to have a basic understanding of Android development. You need to know some Kotlin, and then at least some basic knowledge of Compose.
Jeremy, what if developers want to learn more about Compose?
Oh, yeah, that's a good question. So I've linked it here. You can see that there's tons of great content on Compose. One of my favorite things was the pathway. That kind of is like a checklist where it gives you articles and videos and code labs as well. And then because this is ADS, there were 2 other code alongs, which I strongly recommend you check out. There's one that's an intro to Compose. So that'll cover all the basics. And then there's one on migrating from views to composables.
Yeah, and it's also important to note that everything that you will learn for Compose will translate directly to Compose for Wear OS.
Yeah, exactly. But if you do have any questions that come up during the code lab, you can actually ask us and the team.
Yeah, and today we have more folks who are on the live stream. We have John, Yuri, Steve, and Alex from Wear Engineering and DevRel teams, and they will help us to answer any questions that you might have which are related to Compose for Wear OS, and they will be answering all these questions in the live chat. And I might also bring some questions live as we do the code lab.
Great, let's start. So the first thing you need to do is you need to get the code. You can do that through Git here if you'd use this command. If you don't know it, that's okay. You can just download it here. And when you bring it up, you should have something like this. You're basically going to have 2 modules. The start one is where we're going to do all of our work. And then the finished is, if you get lost along the way, you can kind of use that as a reference, or you can look at what the end result will be. And then obviously we have our Gradle files. So let's run this first. Actually, before I run it, just make sure you have your emulator, and you can get that at the AVD manager. I obviously already created my own, but you just create a new one. You might need to download this while we're talking. So if you go to Wear OS, you can see there's a bunch of options. The most prevalent shapes of devices right now are the round ones, so I'd probably start with that, and then you just click next, and then if you need to download it, you can. The latest version of Wear OS is actually API level 30, which is what I'm going to use. So
and
if I
also,
Oh, go ahead.
Yeah. If we developing for Compose, can developers still use the preview annotation for instant composables preview and styling?
Oh, yes, they can. So here's the emulator so you can see the Compose. I would say check that out, make sure it works. And then if I actually go to finished, maybe I'll do that. Let me minimize that. So you don't have to, we're going to do a lot of our code here in this reusable component. So this is all filled out, what we'll end up making. But if you look here, you can see I've actually set up some previews specifically with where OS size is. So it looks pretty nice. But yeah, we'll do that along the way.
Looks good. Shall we maybe start with the steps which are required to create a new project?
Oh yeah. So if you want to just start coding right away, I'd recommend going to this new, and then if you go to import samples, there's a bunch of great samples across a lot of things here. But if you search for, we'll say Compose, and you can see there's a bunch of great samples here. But if you actually go to the wearable section and hit start, you get this basically this nice little Hello World app, and you just start that. It'll download and set up the project right for you right there. Great. Well, let me give you an overview of the project itself. So obviously you have your Gradle files. We'll cover that in a second. The manifest, that's going to be the same, so I'm not going to cover that. Most of the stuff you're going to do is going to be here. So we're going to have a main activity, which is where everything starts. We'll do a little bit of work there. I'll talk through that in a second. The preview constants, these are just constants I set up so you have a nice where device set up when you're doing previews. So don't worry about that. You don't have to look at that. We'll actually do most of our programming here in this reusable components file. Right now, it's just filled with a bunch of empty composable functions. And then obviously I have the themes where I set up the theme for the whole project. Let's get started on the dependencies.
Yep, so most of very related dependency changes you will make will be at top architectural layers, which Jeremy is showing them. Now, these are the ones which are highlighted in red. However, you will need to use proper Wear OS dependencies for material, foundation, and navigation libraries, which are different from the libraries that you used before on mobile.
Right, so that means a lot of the dependencies you already used for Jetpack Compose actually won't change. So anything down here won't change. But let's just have a look at that in the project, because I think that's easier. So you can just open up the started build Gradle file. And if I scroll down here, by the way, if you look at the code lab and you're following along, I have a lot of to-dos to take you to so you can search and go exactly to the right spot that we're talking about. So check that out. I'm just going to walk through them here because I think it's a little bit better like this. So first, I have my general Compose dependencies. This is the same as you're used to. Here, I actually have, you can see it's a Compose material. You're used to using this on your other projects generally when you use Compose, but you have to use the Wear version.
And actually, Jeremy, maybe before we dive into implementation details, can you explain why developers actually need to use a different version of dependencies for Wear?
Sure. So Wear has its own material theme, so its own color, shapes, and typography, and that's all targeted to wearables. So in turn, other composables, so in that, composable functions like buttons, cards, icons, etc., they all use that theme. And then they even make some of their own customizations themselves. So if you don't use that, then what's displayed is going to be a little bit unexpected as far as fonts and colors and all that stuff. It won't look quite right. So you want to make sure you use that. In addition, we brought over all the ones that make sense on Wear. So some of them we didn't bring over that really don't really fit in Wear. So it's kind of a nice place to guide you in the right direction, but also take care of all that stuff for you as far as making up nice on the wearable. Great. So the next one is, this one is the foundation. So again, foundation, you're used to this one. I'm actually going to add this one here.
But wait, for foundation, we right now have two dependencies. Do we need to keep both?
Oh yeah, so this is additive. So whereas is the material you replace it, this one's additive. So you can actually see up here, I'm using the general one. And the reason for that is we build on top of that. So the key difference is we support round screens. So the Where Foundation includes curved row, so it makes it really easy to lay out content along the edges of a curved screen. Usually you want to use that with curved text, which comes with the material library. And then you can do nice things like curve the text at the bottom of the screen or however you want. Actually, I have a sample that shows that, and we'll make sure we link that. So if you want to do something like that, you can check that out.
Yeah, and we mentioned one more dependency, navigation. What about that one?
Oh, yeah, sorry. Didn't mean to interrupt. Yeah, so navigation, same thing. You want to, this is actually a replacement like material. We aren't using it here, so I'm not going to go into it, but basically this supports navigation, but also our swipe to dismiss, which is kind of like our back gesture for Wear OS. So if you are using navigation, make sure you use that. Great, so that's the dependencies. Now we want to go into, I do want to give an overview of the main activity, and then we'll start coding. So I'll be pretty quick with this because again, I actually didn't make any changes here, but so again, I'll be fast because we kind of expect you to have some compose knowledge. So just like any compose, in this case, I'm using a component activity. I set the content and I call a composable function. And in here, I'm setting the theme. So this is the same standard stuff you're used to. So if I actually look at my theme, you can see here, I'm doing what you would always do in Compose, which is I'm just setting the material theme and then I'm customizing my colors in typography. In my case, I'm not setting the shape, and that's because we've optimized all the shape sizes for both round and non-round, like square and rectangle devices. So we always recommend you don't change the shapes. So that's what I've done here.
And for themes file, is it something inherited from the Android Studio template, or developers need to import themes file every time they create a new project?
Oh, yeah. So the new one, the one I showed where you create that new one, we set it up so that it pulls in a theme just like this, and it sets it up for you. If you made it from scratch, you'd obviously have to create this yourself. But again, if you use that, you'll be all set.
Okay, great.
Yeah, so I've set the theme. Again, I'm going to fly through this. I'm just setting up the lazy list state. You can see down here I have a lazy column, so I'm going to list a bunch of stuff. Let's see. I set some modifiers, so I don't want to set them recreate the modifiers for every composable we're making, so I kind of set them up at the top so we can reuse them. And for you, modifiers are basically a collection of modifier elements that decorate or add behavior to Compose UI's elements. So for example, padding, width, size, you can see that's what I do here. I just make sure it's the width of the lazy column. And then for the icons, because I'm going to set up some icons, I basically set the size and then I align it. Outside of that, we have the lazy column. Again, I'm just setting some standard stuff, content padding, a modifier, the arrangement, and then here's the good stuff. So each of these items will be shown. Right now, these are all empty functions, these ones down here, and those are what we're going to populate. And then up here, this is just a hello world, but that's just so you can see it was working when we started the project.
All right. Does it make sense also cover architecture best practices when using Compose for Wear OS? In particular, should there be always one main activity and the reusable components, or one main activity per screen with shared reusable components?
Yeah, so usually with Compose, you'll only have a couple of user journeys. So you'll just have a couple activities for each screen, so that it's much easier to support swipe to dismiss that way. But with composables, it actually works well. So you want to use one activity and multiple composable screens. And that sample I talked about earlier that shows the curved text, that actually has multiple screens and uses navigation to move between them. So we'll link that at the end. But if you're interested in seeing a one activity, multiple screens example, you can just go and check that out.
Okay, cool. All right, so now we have a better understanding of the project setup. We can start with creating simple composables. And the Compose for Wear OS material library offers many of the same composables that you're probably already used on mobile, but those are optimized for the watch. We will start with 3 composables: button, text, and card.
Right. So we'll start with the button one. If you're following along, you just go to the simple composables. So I'm just going to mainly do this in Studio. So first thing I want to do is I want to get rid of this this hello world thing. By the way, you've probably noticed there's some warnings. That's because I've set up imports already for you. So when you paste in your code, you don't have to manually import everything. As we go through this, you'll start noticing that these will go down. Also, if you really have a good eye, you might have noticed the tabbing's off here. That's just because we're going to paste the scaffold in here, and then the tabbing will be correct. I didn't want you to have to worry about tabbing everything yourself. Okay, so we removed this. Now we're going to go to reusable components. This is where we're going to do a majority of the work. So let's first see what we're going to build, because I think that would help to get a visualization. So we're going to build a button that just looks like this, nice purple little button. And this is optimized for wear. So let's do that first. So first thing you want to do, again, I've got these to-dos so you can find them and you can do a copy and paste. I'm not going to copy and paste myself, but you can do it if you want to follow along. So the first thing I'm going to do is create a row because in this case, I want to, I want to center my text. Otherwise, it'll kind of expand the button out, which I don't want. So I'm just going to set a row where I reuse the modifier that was passed in. That's the one I talked about earlier. And then I'm just going to set the horizontal arrangement to center. Next, I'm going to create the button itself. Oh, sorry about that. So I'm going to do that. So the first thing I'm going to do is I'm going to set the size. The nice thing here is we give you a bunch of defaults that are optimized for wear. So when you set the size itself, I'm just going to choose a large size. The on-click, again, this is a UI demo, so I'm not going to add a click. Normally here, if you had a regular composable, you probably pass in a lambda that then calls up and that's being passed down to trigger something else happening. So I'm not doing that here, but you would want to do that if this was a real app. Next, I want to add a nice little icon. So maybe, let's see, what should I do? We'll do maybe a phone icon. Okay. And then we'll add, this is a content description, so we could say phone action. This is just for accessibility, so it's always good to pass that in. And then I'm just going to do an icon modifier. Okay, so let's see what this looks like. All right, so phone. So there we go. So we have a nice little phone icon. It looks okay. You'll notice the styling's not correct. In my previews, I didn't pass in the material styling because I wanted you guys to see some differences between the final product and the other one. So that's why that's different. I just wanted to make it a little more interesting as we go back and show everything. So this, we'll see it live. So here's the button with my style applied.
Yeah, and one quick point about icons. Yeah, Jeremy, if you get back to rounded font icon. So here we use material icon extended library, which means that you can find that other material libraries may also have Wear OS counterpart. So you should use a specific version for Wear for material icons and for the rest. Right.
Yeah. So yeah, because you can mix and match some of those material libraries. Okay, great. So next let's look at text. This is pretty straightforward. This is kind of what we want to do. We just want some text to appear. So I'm going to do copy and paste this like you normally would if you were following along in the code lab. And I'll just go through these really quickly. So modifier, this is just going to be the full width. Again, you should know what that is. I'm just centering the text. Next, I'm setting the colors. I'm using the primary here. And then after that, I'm setting the string from a string resource. Now, by the way, the previews I've set up as groups, so you can kind of choose which one you want to see rather than all of them at once. So go ahead and choose text, and then we'll see how this looks. All right, so you should say, it's kind of hard to see. It says Square device. which is perfect. So if I run this, it should show up there. There we go. And that says round devices.
Yeah, and we actually have different strings for emulator and preview. Can you maybe explain what happened?
Oh, sure. So let me go back here. So actually, if you look at the resources, we actually support both round and non-round, which is the default for string resources. So you can set the same string, and then WearOS is smart enough to figure out, oh, this is a round device, so I'll serve up the string from this resource versus the other one. So it's really helpful if you want to do a little bit different text based on whether maybe it's wrapped or not. Okay, great. So now we've done that. We've covered all this. Let's look at a card composable. This is going to look like this. So let's have a look at it. Start programming it out. Let me hide this. Okay, so split. So now I'm going to do the card. So let's have a look at this. Okay, card. Oh, actually, before so on when you're building normally, maybe you built for mobile or something like that. You're used to the card composable. Instead, we have two different composables. We have the app card composable, which allows you to have an icon, and then you have title card, which is more text based. But I want to make mine a little bit more pretty, so I'm going to add an icon. That's why I'm going to use app card here. So app card. Where did my cursor go? There it is. All right, so this is pretty straightforward. I'm just going to set the same modifier I passed in before, rounded. So in this case, I'm using, again, the icon extended library in conjunction with this. I'm going to do, we'll say message, and I'll just say this is a message action. Again, this is for accessibility. Again, I'm going to pass in the icon modifier. Modifier. There we go. And then you can see I set a bunch of items here. So I'm going to give you the preview so you can see what it looks like to explain that a little bit.
Yeah, and for those parameters, this works like in a standard compose. So instead of passing strings, you actually have slots here, and you can give more flexibility and add wherever you want to those slots. So it's kind of like a template. Yeah,
exactly. So you can see I'm just matching these up with the things here. So you have like app name would go in this slot, time here, title here, and then content. I only have one, but I could add more of these if I wanted to, if I wanted to build it out a little bit more. But yeah, that helps. I'm just being lazy and just adding text composables, but you can definitely do more. So let's see what this looks like. All right, so there we go. There's a nice little card for you. So at this point, you're probably seeing like all these simple composables like, oh, these look almost exactly like what I'm used to. If we actually looked up top, you'd see the only difference is really they're coming from the Where libraries. By the way, again, you're probably seeing errors as we go through these disappear again. I wanted to make sure I imported everything for you so you didn't have to do it yourself. And then, okay, so we're done with the simple composables.
Jeremy, I think it might be worth mentioning where developers can find the full list of available components.
Oh, yeah. So this is really actually handy if you do this a lot, which I do. If you go to developer.android.com/jetpack, there's this really handy API Explorer that I use all the time. It's right here. You just search for whatever you want. It could be the use case. It'll match you to the library or just the library itself. In this case, I'm going to do where. And you click and it takes you right into the release notes. And you can kind of see what's happening. You can say, oh, wow, yesterday released another release. Awesome. But it also takes you to the API reference, which is super helpful. So this is where like you can see everything you need. I'm on a little bit of a smaller screen, so you can't see, but usually I have a list here as well. If you scroll down, you can see all the top level functions. And this will actually give you a list of all the composable functions you can use. And if you're more into the doing it on here, you can do that as well. You can just click in, just right click and you can go to the implementation, and it should give you, you can see a list of all of them. So you can see the text is here. It gives you explanations. If I make it all code, you can just go through and read all of these. So that's a bit of an easier way if you want to do it that way.
Okay, and perhaps we should also show where developers can find the latest Where material guidelines for app overlays.
Oh, yeah.
I mean UX guidelines.
Yeah, so if you go to developer.android.com/where, this is just the main page, but we have like I won't dive too deep into it, but we have design guidelines where we kind of walk through everything. There's a whole list of them. You could go to overlays. It explains it all. Check it out there.
Okay, cool. And just to remind that if you have any questions about Compose for Wear OS, feel free to ask them at the live chat. We have folks from Wear engineering and DevRel teams who are helping and answering your questions over there. All right, so we already know how to build very simple Wear OS components, and now let's actually look for the most interesting stuff, and in particular, how to create very unique composables, and what are the steps that you need to take to customize and build such components for your app. So let's start with the chip.
Yeah, so chips are meant to be a quick one-tap action that makes especially good sense on Wear with its limited real estate. And chips are actually specified in the material guidelines, which I point out here, but there isn't an actual composable function right now in the main material library, but there is in the Wear one. So this is what they look like. You can see it can be as simple as this, or it can be more complex where you have an icon and multiple text fields. You can even have a background like that to make it really pretty if you want. The one I'm going to be building is going to be fairly simple. It's just going to be this little meditation chip. So let's go over here. I'll scroll down to the chip example. So let's see here, chip. All right, so the first thing I want to set as my modifier. Again, this is the same as I've been doing. But the on-click, again, this is more of a UI demo, so I'm just not going to do anything there. Now, I do want to set a label for this, so I create a text, and we're going to say it's 5-minute meditation. For max lines, I want to do just one. So what this means is the text, it'll just do one. And then I can say if there's overflow, if there's too much text, what do I want? So if I say ellipse, it'll basically cut it off and then add ellipses. After that, I just want to add an icon. So let's see if I can remember this. We'll say self-improvement. We'll say meditation. And then again, the icon modifier is what I passed along the whole time. So if we actually, oops, I should have showed this, and let me minimize that. So let me go to chip, and then we'll just build it up so you can see it live. And this should show us what a chip would look like. And you can see the code's quite simple. And that's the chip. And then if I actually run it, I should get my theme applied. Yep, there you go. There's the chip. All right, so let's talk about toggle chips next. Just close this out. So I want to again show you what it looks like. By the way, I added some examples just so you can see. So this is what a toggle chip looks like. It's just a one tap type action you can do. So ours is going to look like, we're just going to have a sound one like this. So I'll just go here. About toggle chip. Okay, so the first thing I'm doing is because I'm going to show that turning off the switch off and on, I'm going to actually create some state. So I'm doing that through the remember call. So this is going to keep it available through recomposition. And then I'm setting a mutable state. Pretty straightforward. You should know this if you're used to compose. Again, modifier, I just want to set the same modifier I'm used to, or that I'm passing in, sorry. Checked, I'm going to pass in that check state I just created. Switch icon. So I talked about this. Well, I haven't talked about it, but so you can set a, you can do a checkbox. You can do a radio button off, a radio button on. There's lots of options. In my case, I'm just going to do the switch icon and just pass in checked. Again, so this is just the callback. So I'm just basically saying, changing this, the checked variable to it when it's passed in. And then I'm just going to have a label. So I'll just say sound. Again, I just want one max line. And then if it's too long, I want to cut it. I'll have it cut with some ellipses. And then if we actually look at what it would look like, we should get it here with, and again, this won't have my theme applied, but you can see that for the default, it does this nice gradient. And then if we actually run it, you should see it show up here. And then I can switch it off and on once I get it here. So this should have my theme. You can see that it has this nice gradient across with my purple theme. And then this is a color I set as well. You can see it turns off and on.
Yeah, and there are also other options to customize toggle chips. So for instance, you can set the background, use a checkbox or toggle, but also we offer split toggle chips, which allows you to create a chip where left half is for handling a click event and the right half is for toggle itself.
Right, and here's the example so you can see it visually.
Yeah, and chips are one of the basic building components that we recommend for Wear OS, which are part of our UX guidelines. Okay, shall we move to the next section?
Yeah.
Yeah, and we're going to talk about very specific version of lazy column, which is called Scaly lazy column. Yeah, so you may know that lazy column is used on mobile to produce a vertically scrolling list. On Wear, we have round devices, which means that we have a smaller sizes at the top and the bottom, and in general there is a less space to show items. Therefore, to better support such round devices, we created our own version of lazy column, which is specific for Wear OS. And in the nutshell, scaling lazy column extends lazy column to support both scaling and transparency at the top and bottom edges, and also to make content more readable to the user. As you can see on the demo, right now that Jeremy is showing, each list item scales up when it gets closer to the center, and then it scales back down and also gets more transparency.
Yeah, exactly. And here's a concrete example with an app. You can see at the top it gets smaller and at the bottom as well. So this is actually really easy to do. So we're done with the, let's see, we're done with the reusable components. We've done all that. Let's have a look at the main. Now we're going to make our last changes to the main activity. So, so if you look here, you can see we have a couple to-dos we need to do. First thing is we have a scaling lazy list state. Well, we want to use we have remember lazy list state. We want to change this to remember scaling lazy list state. And now we should have an error because a lazy column doesn't take this type of state. So we just have to change this to scaling lazy column. And then it's not going to look any different here. So I won't show that. But if you actually run it, that's where you can kind of see it. So give it a second to show up here. And there we go. So now if we actually look, you can try this at home. You can see it actually scrolls down and gets a little bit smaller and disappears. Same with the bottom, it kind of scrolls down.
Yeah, but can we also customize how scaling works?
Oh, yeah, you can. Actually, I have a block I can show here. Let's see. So this is just a customization to make it really over the top. So I'll run that, and then you should be able to see it there. Okay, so if I do it now, you can see it really gets large and really small. So you can really like change it a lot. In our case, we're not doing that, but though the default doesn't do that, but we're doing it here. Great. So now we're down to the last step, which is the scaffold. Do you want to cover that, Ksenia?
Yep, absolutely. Okay, so the scaffold is the last one component that we're going to cover today. As you may know, there are some common UX patterns that we require developers to follow on Wear OS, and the scaffold provides a layout structure to help you line up components into these patterns. It works in a similar way to scaffold composable on mobile and gives pre-built templates for 3 Wear-specific layouts, which includes such top-level components like time, vignette, and scroller position indicator. Yeah, and I think it's worth mentioning that Scaffold already handles both round and square devices, which make things even easier for you. Okay, so you see that Jeremy is showing how those components look like, and let's quickly cover each of them. First one is a time text, and regarding our latest Wear material guidelines, we require apps to display time at the top of any screen within app overlay. So this composable already uses curved text under the hood and gives you a simple way to show the time without any extra work. The second one is vignette. A vignette adds a blur effect at top and the bottom edges of the screen when the screen is capable for scrolling. And the last one is a position indicator, which also known as a scrolling indicator. And this component is aimed to show the current progress on the right side of the screen based on the type of the state object that you pass in. And I guess in our code lab, we'll use scaling lazy list state as an example.
Right. Okay, but before we can do all this, we have to set up the scaffold. So go ahead and copy this, and then we'll go over, I guess I can leave that there for now. So if I go here, you can see this is the to-do. I just paste it in here. If you actually press enter, it'll fill out the other bracket. So we've done that, so we can take off the start one. And then we can cut. I'm going to cut this, and I'm going to go down to the end part where it says end, and then you just add it there. Now, if I actually run this, you'll see that there's actually no difference because I'm just creating an empty time text vignette. But let's fill that out now. So yeah, there's no difference here. So you can just copy this code. I'll just show you that because that's pretty easy. I think we talked about time text. That's pretty well covered. So I'll just copy this. And then if we just replace this, what I'm actually doing here is because I moved up the state, I can check if it's scrolling. If it's scrolling, I don't want to show the time text because that can be that can interfere with the content. But if it's not scrolling, I want to show the time text. So so if I actually, let's look at the preview just so you can see it first. And this will show you like a square type device. And it should show up. Give it 1 second. There we go. So you can see it's straight text there. But if we run it on the emulator, it should show up as rounded text. Yep. Really easy.
Indeed, very easy. No need to deal with any time classes.
Yes.
Okay, I'm also wondering if developers can do a curved text outside of time class, time component.
Oh, yeah. So you remember earlier I was talking about the foundation that had that curved row. so you can put a curved text in there. So yeah, you definitely can do that. The sample I'll point to at the end does that, but you definitely can.
Okay, great. So let's move to the next one, vignette.
Okay, so the vignette, again, a lot of you may not know this, but a vignette is a pretty common term in photography for adding kind of this dark blur on the outside of a picture. So that's where that comes from. But again, you're just showing the blur down here. So this is actually really easy to do. So just copy this, go over to vignette and just paste that in. Really, the only thing I'm doing here is, let's show this. I'll load it as I'm talking through. So really all you're doing is you're setting a position. So it could be in the top, it could be on the bottom. Generally you want it on the top and bottom. So that's what I do here. And when this loads, it should have, you can see this really visible vignette here. But if we actually run it, you can see better what it looks like live. So when I scroll up, you should see now, oh, it's kind of hard with the time. You should see this like darkening at the top and then even at the bottom with the 5-minute meditation.
Okay, and maybe to reiterate, what are the cases when vignette should be used?
Oh, yeah, so you don't want to show a vignette all the time. You basically want to show it when you have like a scrollable type screen. So in my sample, I only have one screen and it's scrollable, so I'm showing it. But you'd want to keep some sort of state, if not, and then you basically don't want to show it if it's just a simple non-scrolling screen. All right, so last is a position indicator, also known as the scrolling indicator. So let's do that. So again, this is this little thing right here, and you're probably wondering, some of you might be wondering, well, why isn't this, part of the lazy column or scaling lazy column? And the reason is that for composables that don't take up the whole screen, it'll be cut off. So, and it looks weird. So in this case, here's an example where this top part is not part of the scrollable list, but this part is scrollable. And you can see if we center it to this viewport or this, whatever we're using here, most of it's cut off because it's, it's a round screen. So you have to kind of set it to the whole, the device itself. So the whole thing, opposed to just the individual viewport. So if you do that, then all of a sudden you get this nice scrolling indicator, position indicator, I should say, there. So it looks right. So that's kind of why it's kind of up at that level. But this is actually really easy to do. So you just copy this, paste it over here, and really it uses the list state to kind of figure out where it is to show it properly. So again, we've already moved up the list state here above the scaffold. That's called hoisting. You can learn more about that later if you don't already know, but I've just moved it up here so I can access it here. And so if I actually, the preview shows it as well, so you can see what it looks like on a square device. And then I'll show what it looks like on a round device. So give me a second here. Yeah, so there's what it looks like. It's straight, but if I run it on this, it should be curved. The other nice thing about this is it disappears when you stop scrolling, which is a nice feature. It does that automatically. So you can see here the time will disappear, scrolling will show up, and when I let go, it disappears, which is great. And then,
yeah, for position indicator, does the position indicator only support scale in lazy list state?
oh, no, it actually supports many more. So you can do scroll state, you can do lazy list state. It can do some other stuff with buttons and side buttons and rotating bezels too. So there's lots of options.
All right. Yeah, actually, in fact, we didn't even name it as a scrolling indicator because of because of possibility to handle rotary input events. And for developers, it might be good to know that you can use rotary input events for handle such things like controlling music volume, and those are also available within scaling lazily state.
Yeah. Oh, that's very good points. And then here, so we've done this. Oh, we're at the end. Awesome. Congratulations. Hooray, you did it. So what's next? Maybe first I dismiss this. We have some other code labs. Those aren't Compose related, but you can check them out. They're where related. If you want to read more about Compose itself, we have a blog post where we wrote a lot about it. We put together some simple and the complex sample. That's the one I was talking about with a single activity and multiple screens that you can kind of move around with navigation, handles all that stuff. And then I point again to the Compose training. And again, we want to follow what the bigger Compose team did, where they kind of came out early and got a lot of feedback from developers and incorporated that into the release. So this is a developer preview, and we want you to influence the API. So make sure you share your feedback. Either we have a issue tracker here. You can add it there, or you can run JetBrains, the JetBrains Slacks, the Kotlin one, and we have a Compose Where channel. And I and a bunch of the engineers and Ksenia and a bunch of us are on there. So make sure you can go there after the case and say, let us know if you feel like something's missing or not.
Okay, cool. Again, well done, everyone. And we have some questions that are coming to us. One question was about, is there any editor, like motion layout editor, for the animations on Wear OS? So right now, we have some updates for IDE coming in soonish time. And yeah, we'll update developers as soon as we have more guidance around tooling. And also, just to mention, we also have some more components on the roadmap, such as speakers, sliders, progress indicators, and simple dialogues. But in case if you need other components that you would like to see on Wear OS, please submit the feedback. Please let us know. We are very approachable to developers' feedback.
Yeah. Definitely, the more feedback, the better. We want to hear what we need to make you successful on Wear.
All right, let's wrap. So yeah, again, as I said, there are more changes in our roadmap. So we encourage you to join our dedicated Slack channel, as Jeremy mentioned, so you have ability to share your feedback and bring your questions directly to the Google team. And also, just to remind that Compose for Wear OS is currently in developer preview. So it's a really good time to start experimenting and scaling your existing Compose knowledge to Wear OS.
Yes.
Thanks for joining us today.
Happy coding.
Happy coding. Bye.
Hi, I'm Clara Bellarri, an engineering manager on the Android Toolkit team, working on large screens and Jetpack Compose.
And I'm Daniel Jacobson, a product manager on the Android developer team for foldables, tablets, and large screens.
You may have seen some big announcements in the keynote, including our 12.0 feature drop, upcoming updates to Play Store to assess large screen app quality, and more. In this talk, we'll focus on the developer tools and libraries that make it easier for you to scale your app's UI to support a wide range of screen sizes. We'll walk you through a collection of APIs and tools which help you make the most of your UI as screen sizes scale up. Before we jump into all of that, though, why are we making such a fuss about large screens? In the last 12 months, we've seen nearly 100 million new tablet activations, and Chrome OS grew by 92%, the fastest growing desktop platform. This means that there are over 250 million large screen devices running Android across tablets, foldables, and Chrome OS devices. Speaking of foldables, we've seen foldable devices on the rise, with year-on-year growth of over 250%. Device manufacturers are increasingly recognizing this form factor as a device differentiation opportunity in the premium phone segment. With the rapid growth of tablets and foldables, it's time to stop thinking about phones and tablets separately. Design and build your app for the ecosystem to increase your app's reach in the market. In the upcoming months, Play Store will be introducing new incentives for developers to target large screens, including per-device type app ratings. It is now time to get ready for these changes to ensure great app ratings across all device types. Doing the work now will also ensure your app avoids awkward user experiences, such as having your app letterboxed on large screen devices because your UI isn't scaling properly. We've already observed business success from apps who optimize for all screen sizes around metrics such as user engagement and user retention. Let's look at another success story, Candy Camera. After building optimized layouts for foldables and large screens, including a tabletop-specific snap and view mode, they observed users of Candy Camera on these devices spending 10% more time in the app and a 14% increased 7-day user retention. And it's not just Candy Camera. A variety of apps are building optimized layouts for large screens and foldables to capitalize on this fast-growing device segment. Another example is Microsoft Outlook. Recent updates to Outlook take full advantage of larger displays, with the 2-pane layout to see your inbox and email contents at the same time, and the ability to compose a new email in a separate window with multiple displays. It's time to break out of the phone and design and develop responsibly now. But don't worry, we're doing a lot to make it as easy as possible for you across the development lifecycle. Let's jump right in.
We've heard from you that knowing what screen sizes to design and develop for is difficult within our diverse device ecosystem. We're working hard to make it straightforward for you to build a responsive UI that works well across phones, tablets, and other form factors. For the future of resizable Android apps, we've dug deep into Android device market representation. We also took some inspiration from responsive and adaptive web development best practices. The result is a new foundation for building resizable Android UI. This new system is called Window Size Classes. Window Size Classes are a set of opinionated viewport breakpoints for you to design, develop, and test resizable application layouts against. These breakpoints will help you understand the key sizes to optimize for to ensure your app covers as much of the ecosystem as possible. The Window Size Class breakpoints have been broken into 3 categories: compact, medium, and expanded. They have been designed specifically to balance layout simplicity with the flexibility to optimize your app for most unique use cases. The recommended usage of these breakpoints is to make high-level application layout decisions, and they also map to the material layout breakpoints for layout grid column changes. New Window Size Class APIs coming in Jetpack Window Manager 1.1 will enable you to break away from error-prone is-tablet Boolean logic that has become especially fragile with the introduction of foldables. These new APIs will also negate the need for custom logic around landscape and portrait configuration changes for most cases. You'll just be able to design for the different Window Size Class breakpoints, and your app will adapt to the right layout in various app states. One important thing to mention is that Android applications can be arbitrarily resizable, and all applications run in multi-window mode, beginning with Android 12. In the keynote, we mentioned that we've seen a 7x increase in split screen usage on the Samsung Galaxy Fold series from the larger screen real estate that the inner display provides. Split screen apps can be resized to match user preferences, further emphasizing the importance of building resizable UI. We also recognize the familiarity with thinking about layouts in terms of devices and configurations. To make things a bit easier, each size class breakpoint represents a majority case for typical devices and configurations as seen here, and this can be a helpful frame of reference as you think about the design of your breakpoint-based layouts. To be explicit, compact width represents your typical phone in portrait mode. Medium width represents tablets and larger foldable inner displays in portrait mode, and expanded width represents tablets, larger foldable inner displays, and desktops in landscape mode. In addition to these 3 width-based breakpoints, we are introducing height-based breakpoints with the same category names to provide additional flexibility for more advanced layout scenarios, such as optimizing for landscape phone UIs using the compact height breakpoint. We've heard this can get a bit complicated, but don't worry. After speaking with many Android developers, we have evidence to suggest that most of you will only need to adapt your applications based on width. To summarize, window size classes represent a big step in adaptive and responsive layout development in Android across updated and improved guidance, new APIs in Jetpack Window Manager, and new tools in Android Studio. Speaking of Android Studio, I'm excited to introduce a new category of tools coming to Android Studio Bumblebee called reference devices. Since Android apps should be built to respond and adapt to all devices and categories, we're introducing reference devices across Android Studio in many tools where you design, develop, and test UI and layout. The 4 reference devices represent phones, large foldable inner displays, tablets, and desktops. These reference devices have been designed after analyzing market data to represent either popular devices or rapidly growing segments. And they are also designed to enable you to ensure your app works across most Windows size class combinations. If you just take one thing away from this talk, remember this checklist. To make sure your application scales well across devices, optimize your layout for both compact and expanded width size classes. Next, test your app on all reference devices. Every app is different, so pick the layout that works better on medium width size class screens for your app. And to make your app really stand out, consider additional improvements such as custom layouts for foldable hinge postures, or a custom layout for the medium width breakpoint or height breakpoints. Also, don't forget about how users interact with larger screen devices, often with additional input tools like keyboard, mouse, and stylus. You can find more details about Windows size classes in our docs, and you'll see both Windows size classes and reference devices appear throughout the rest of this presentation. For an example of Windows size classes in action, check out our JetNews Compose sample.
The first step to supporting adaptive UI is designing your app in a way that behaves nicely on both a small and a larger screen. This may be quite intimidating, like facing a blank piece of paper. It's important to consider how your application will be used in different contexts and what you want to enable with the additional screen space. We've been working on new material design guidance that will help guide you scale your app's UI. We've published guidance on common UI structures prevalent in the ecosystem that will help inspire and kickstart your efforts. Leverage these resources to make it easy to get started with layout ideas and enhanced designs across phones, tablets, and folding displays. For a more detailed explanation of the new guidance, check out the Designing Beautiful Apps on Foldables and Tablets talk. Designing a beautiful, responsive UI is the first step, but knowing how to implement and maintain that design can be a real challenge. Whether you have an existing app with a set architecture or are looking at starting from scratch, we have some tools to help you along the way.
Let's see how we can update an existing app to rapidly optimize for all screen sizes with the help of new Jetpack APIs and Android Studio features. We'll use Tracker, an open source sample task management app that we've recently updated to better support larger screen devices. Tracker was developed to showcase accessibility best practices within Android, and with the recent updates for large screens, you can use this as a great example for your app. Let's take a look at what we did to make Tracker work great on large screen devices. Before we made any changes, this is how Tracker looked. Regardless of device or screen, we had a single pane list of tasks with a bottom app bar for navigating to an archives or settings screen. The application has 5 main views: a list of the tasks, each task's details, a screen to create or edit tasks, and a settings and archives view. The navigation graph, before we've done any large screen optimizations, flowed like this, with the list of tasks acting as the home page, enabling navigation to the settings or archive page. Now, let's optimize this for large screens. If you're not sure where to get started in your own app, the first thing you can do is use new tools to identify potential issues impacting large screen devices. In Android Studio Chipmunk, we're working on a new visual linting tool to surface UI warnings and suggestions in layout validation. In Tracker, we can use layout validation on existing layouts to surface some potential large screen related issues. I can start with the top of my navigation tree to get a good high-level overview of how my app will behave. I'll start by opening my main activity layout, and then I'll open the layout validation tool. If you don't see a layout validation, you can go to View, Tool Windows, and select it there. The first thing you may notice within layout validation is the new Reference Devices validation category. This is one area where you will see the new Reference Devices feature appear in Android Studio. I see a warnings icon in the top right of layout validation. Clicking on this opens the warning pane, and clicking on each warning shows me which reference devices are impacted. In this case, I see 2 warnings specifically related to large screen layouts. Bottom app bars are only recommended for compact screens, and Material Text View has lines containing more than 120 characters. I can expand each warning to see that the warning also provides a suggestion. The suggestion for the warning related to the bottom app bar is to use a navigation rail, navigation drawer, or top app bar instead. For Tracker, I think it will make the most sense to use a navigation rail. The suggestion for the warning about the Material Text View control is to either decrease the width of the text view or consider a multi-column layout instead. In this case, a multi-column layout would work great for our app. Let's work to resolve these warnings by implementing a typical list details pane style app for the tasks list. To recap, our desired end state will have two new layout optimizations. For medium width device classes and larger, we'll have a nav rail instead of a bottom app bar. And for expanded width device classes, we'll also present a two-pane layout to show tasks and associated details. Let's start by focusing on the first optimization, adding a nav rail instead of a bottom app bar. The first thing we need to think about is our navigation model. Fortunately, our navigation graph is impacted minimally. We aren't changing the screens we have to navigate to, but the nav rail will expose the full nav graph on each display because the nav rail will always be present. With that in mind, our updated navigation graph would look like this. The app start destination is still the task screen, and selecting an individual task will navigate to task details. However, from the nav rail, I can navigate to any other view. To implement this pattern, I can add a navigation rail view to my main activity layout. Previously, main activity consisted of just a fragment container view with a coordinator layout to host the other fragments through the nav host fragment. By placing the navigation rail view at the main activity layout level, it will persist across all views. That said, I only want the navigation rail for screen sizes with a width of 600 dp or larger. One easy way to achieve this is to add a resource-qualified main activity layout and add the navigation rail view at the same level as the fragment container view containing the nav host fragment. We'll also want to update our tasks fragment to remove the bottom app bar from displays with a width of 600 dp or greater. Similar to how I implemented the nav rail, I can add a resource-qualified layout for the tasks fragment. I can then remove the bottom app bar and associated floating action button. Everything else remains the same so that my list of tasks hosted in a recycler view will continue to work as expected. Last, I can set the ID of my nav rail menu items to match the ID of my existing navigation destinations, and then set up the nav controller for my nav rail in my main activity code. Now that that's done, let's take a look at Android Studio to see if things look right. We're bringing reference devices to the layout editor, so as I'm working on these updates, I can quickly toggle between the various reference devices to make sure I'm seeing the expected layout. When looking at the phone reference device, I still see the bottom app bar as expected. When looking at anything larger, I see the nav rail. Perfect. Now that our application is using a navigation rail view, let's move on to display a two-pane view for expanded width devices. One easy way to support a two-pane layout is to use sliding pane layout. What's great about sliding pane layout is that it allows me to easily reuse existing layout code. Let's again consider the updated navigation graph. As a quick refresher, this is the current state of our application. The navigation rail view allows me to navigate to any top-level layout within my app, and I can still navigate from the tasks fragment to the details fragment by selecting any individual task. When we implement sliding pane layout, our navigation graph will change a bit. We'll be adding a new layout, two-pane tasks, to include the sliding pane layout, and this will be the new start destination for our application's navigation graph. This layout will contain both the tasks and details fragment. By updating our application's navigation this way, we will have the same navigation graph for the app regardless of screen size. This means resize events won't confuse users with unexpected app navigation. Because both tasks and details will be presented in the same new fragment in sliding pane layout, we'll add a new sub-navigation hierarchy specifically for the navigation interaction for this fragment. This will make sure that when I select a task, and then my app goes from two panes to one pane, that item will be on the top of my navigation stack and will be visible. This could happen if I was folding my foldable, for example. To be more succinct, the navigation from tasks to individual details will be broken out of the app's top-level navigation hierarchy and will be managed separately by the sliding pane layout. To summarize, I will add a new fragment using sliding pane layout and fragment container view to host the tasks and the details panes. This means I don't have to do major refactoring within my existing layout code, which is great. Then I will update my top-level app navigation hierarchy to make the new two-pane fragment my app's start destination and remove the details destination from the app's navigation graph. Next, I'll add a new navigation graph specifically for the sliding pane layout. Finally, I'll handle the sliding pane layout nav controller configuration logic in my tasks two-pane fragment Kotlin code. All right, with those two changes to our application, I think it will look much better across different device form factors. Let's find out. First, let's take one more look at the layout validation for my main activity to see if everything looks right. Great, I'm seeing the right layout for each reference device in just one view. Now, to test things at runtime, we can use the new resizable emulator coming with Android Studio Chipmunk. The resizable emulator lets me quickly toggle between the same reference devices. This means you can rapidly go from validating your layout at design time using layout validation with reference devices to confirming the behavior at runtime using the resizable emulator and the same reference devices. First, I can see I have a single pane application with a nav rail on foldable inner screen displays. This represents the medium width size class. If I try it on the phone display, I get the single pane view with the bottom map bar. This represents my compact width size class. Finally, when testing on a tablet or desktop, I get the nav rail with my 2 panes. One other great attribute of sliding pane layout is that it scales well to not only large screen devices, but also devices with multiple screens. Microsoft recently contributed to sliding pane layout to support hinge detection to split the panes across displays in the presence of a physical hinge without any additional code. This means our application's new list detail layout will scale well to all devices, including those with multiple displays. With those changes, we have a much more adaptive Android application, optimized for each width-based window size class breakpoint. While this is a great way to apply a large screen optimized layout to an existing application with fragments, we know many of you have applications based on multiple activities. For those apps, the new activity embedding APIs released in 12L make it easy to support new UI paradigms, such as a 2-pane view. One other thing we're working on is updating sliding pane layout to support using multiple activities with the new activity embedding APIs. Look for an update in the coming months.
In addition to making it easy to update your existing apps with adaptive UI best practices in mind, we're excited to introduce Jetpack Compose as one of the key tools in your pocket to make it easy to build large screens and diverse UI layouts. If you're starting to adopt Compose, this is a great time to also consider optimizing for large screens along the way. Compose reached 1.0 this July, and since then we've seen tremendous reaction from the Android developer community. Tens of thousands of apps are already using Compose in production, including the Play Store itself. Compose is a declarative UI toolkit, meaning you describe how your UI should look like based on state, and you let Compose figure out any updates needed. All UI is described in code, and it's easy to make decisions at runtime on how your UI should look. Notice this is a big difference with the view system, where we rely on resource qualifiers to describe different screen configurations at compile time. This makes Compose especially great for developing adaptive UI, as it's very easy to handle UI changes across different screen sizes. No matter how many improvements we make to the existing View toolkit, it will never be as easy to adopt these sort of changes as it is with Compose. In the last few months, we've been updating our JetNews sample to really shine on large screens. Let me show you some of the steps we've taken and how Compose made it easy. The main screen in JetNews is a long scrolling list of articles. Before any optimizations for large screens, this is what the app looked like when scaled to a larger screen. This is not a good use of the additional screen space, and there was a lot of room for improvement. Before we're able to make any changes for large screens, we need to know when our UI is being displayed in a larger setting or not. To do that, let's start by looking at how to use the window size classes from Compose. We've covered the window manager APIs earlier, and we're working on a Compose integration to make it even easier to access this information from Compose. In the meantime, we can create a composable function that handles the integration with Window Manager. We can reach out for the window metrics of the current backing activity and remember them correctly as Compose state, and then translate those to a DP size available to the app. Once we have the available size, we can easily translate it into a window size class, compact, medium, or expanded. The Window Manager library will soon expose APIs for the classes directly, and Compose will have APIs to do this for you as well, so stay tuned for those. In the meantime, you can borrow this integration code from JetNews. Now that we know how to gate decisions, let's start like we did with Tracker earlier, by looking at the UI paradigm for navigation. JetNews doesn't use a bottom navigation like we saw earlier, but instead has a navigation drawer that appears from the side as a modal when you click on the logo in the top app bar. However, when we run the app on a large screen, we can see that this UI just does not fit at all. The modal stretches to fill the entire screen, showing a huge amount of white space. The guidance, like we saw earlier, is to use a navigation rail on large screen devices. Compose now supports navigation rail, and all we have to do is set up and pass our content. The header icon and the 2 navigation item icons, one for the home screen and one for the interest screen, with their corresponding navigation actions. To integrate the navigation rail into the app, we made some changes to the top-level app component. First, we reach out for the current window size class, and gate showing the modal drawer on the size being compact. Then we ensure we set up the modal drawer so it only enables gestures in the size, and conditionally place the navigation rail side by side with the main navigation graph, which contains all of the screens in the app. Now that we have a navigation rail in place, the next thing that caught our eye was that the list of articles doesn't stretch well, and we still end up with a lot of wasted white space. So we decided to build a list detail layout on large screens. List detail layout is one of the recommended large screen canonical layouts in material design. It will allow us to show the list of articles side by side with an open article. Building a list detail layout is quite simple to begin with. JetNews has 2 existing components that we will reuse, PostList and PostContent. Ensuring we break down the UI like this into components not only makes it easier to test, but also enable us to evolve the screen layout without having to start from scratch. These components don't assume they have the entire screen space available to them, and therefore we can now place them in a different configuration without rewriting them. In order to show the feed and post side by side, JetNews simply uses a row with the 2 components. The first one has a fixed width, leaving the second component to fill the rest of the screen. The detail component is wrapped in a crossfade animation. This allows users to interact with the list and see nice transitions when opening different articles. Beyond the actual layout, to build a list detail structure properly, we need to solve a couple more problems. One interesting bit is thinking about how the app may transition between different size layouts. For example, when you have a foldable phone, the app may go from the larger screen to a smaller one. To properly handle how the list and detail panes collapse into a single pane hierarchy when on a smaller screen, we need to know what pane the user last interacted with, as that's the one that we will want to show on top. For that, we implemented a simple custom modifier that records the last interaction, and used that further up the hierarchy when deciding what to show in a collapsed state. A final big decision left to make here is at what screen size do we shift from showing only one of these panes at a time to showing the list detail layout. In JetNews, we query the window size class as we showed earlier, and show a single pane for compact and medium, and a list detail layout for expanded. Now that we have the UI pieces in place, let's look at what changes we had to do to get navigation working correctly. JetNews was originally built with the home screen and the article screen having their own view model each. The integration between navigation and view model implies that there can only be one view model per navigation route in a graph, but this was fine as the 2 screens were always shown on different navigation routes. However, to restructure the UI into a list detail layout, we need to take these 2 screens and be able to show them side by side. There are 2 options we can proceed here. We can either nest a nav host in the detail side, enabling a new navigation hierarchy inside the detail pane, or we can unify the view models. Note these options are not specific to Compose. We would face the same options with views and sliding pane layout. If we decided to go with the first option, we would insert a new nav host in the hierarchy that contained the article screen shown in the detail pane. With this option, we could continue to then expand the navigation hierarchy inside the detail pane to further screens, enabling it to operate independently from the list pane. However, in the case of JetNews, the detail pane just doesn't navigate further. It will only ever show one open article without further navigation. We therefore decided to go with the second option, unify the 2 view models into one, to simplify the structure and enable both screens to be shown at the same destination. Notice also how our screen component structure changed. To enable showing either a single pane or a list detail layout based on size, we created 3 entry points to the home screen. Home feed screen, which displays only the post list, article screen, which displays the post content, and the new home feed with article detail screen, which contains our list detail layout showing both the post list and post content. Here's what JetNews looks like now in an expanded size. Notice our use of space is much better than before when we had a stretched list of posts. But beyond the list detail structure, we've also enhanced JetNews in other ways. The interest screen, for example, shows a long list of topics, but it didn't make good use of the space when stretched to a large screen layout. To solve that, we grouped interest into sections and broke down the UI into columns where there is more space available. Now's a good moment to take a step back and look at the different components that Compose provides to build adaptive UI. We've seen that when we want to make decision at the screen level, for example, changing from a single pane to a list detail layout, we want to use window size classes. But what about decisions that are not about screen size? We may want to adapt the UI in an individual component based on the size it has available to itself. For example, we may have a card that when shown with little space inside a list, it displays only a title and a subtitle. But when we have more space, it grows to also show an image. For these sorts of cases, we can reach out for box with constraints. Box with constraints behaves like a box layout, but provides in its scope measurement information that can be used to make decisions, such as when to show an additional image or text. In this example, we are using the max width exposed in the given scope. You should be aware, however, that box with constraints comes with a cost. Unlike most composables, it can't begin its composition work until the measure phase of layout, when it can obtain the size information we want. This may leave your app with less total time to build and display the UI inside of it. Use box with constraints when you want to display completely different content based on available size. If all you want is to measure and position content differently, with no difference in what elements are being composed, as we saw with the shift to 2 columns in the interest screen, you can use a custom layout to achieve the same result with better performance. Check out the A Deep Dive into Jetpack Compose Layouts talk to learn more about custom layouts. So to recap, for screen layout decisions, use window size classes. For choices between different content, use box with constraints. And for laying out content in different ways, use a custom layout. We mentioned earlier that foldables in particular are seeing a huge market growth. Let's look at how to target these devices with hero experiences. Similar to how we reached out for the Window Manager APIs to access window size classes, we can easily integrate Compose with the feature and posture APIs for foldable devices. These APIs tell us when there's a feature on the device, such as a hinge or a fold, and whether the device is in a posture, such as tabletop. Compose can easily observe the state given by these APIs, which enables great UI transitions across scenarios, such as a foldable device going from being unfolded flat to being folded in tabletop mode. We started exploring this in our Jetcaster sample, which implements a podcast player. Making use of the feature and posture APIs, we can detect tabletop mode and adjust the UI to display a player on the top half of the screen and controls on the bottom. To do that, we can detect the current device posture by reaching out to Window Manager for the window layout info, tying the flow to our lifecycle, and then mapping the layout info to different postures we are interested in, such as tabletop. We define tabletop as the case when the device is half opened and in a horizontal orientation. Then we use this posture as data for our composable function defining the player screen, where we decide between 2 possible layouts. We take this decision at the top level of our screen as our design is significantly different between normal and tabletop postures. Once again, APIs in Compose where this integration is super simple are coming soon, so look out for those. Beyond the APIs we've shown until now, we've been hard at work on the internals of Compose to enhance our input stack, including keyboard and mouse support. This is especially helpful for apps running on Chrome OS, as we're making sure your app works great out of the box and enabling use cases across a fast-growing market. To know more about specifics of Chrome OS and input, check out the Input for All talk. Compose makes developing adaptive UI from scratch easy, but that doesn't mean it can only be used in greenfield apps. It's also possible to use it to implement your larger layouts and reuse existing UI via interop. Check out our interop guides for more information on how to mix views and Compose in your app. You can find the samples we've showcased here and their complete implementations in the Compose samples repo on GitHub, and you can easily import them into Android Studio. We've also published new Compose and large screen guidance, and we're keen to see how you can think about adaptive UI as you start adopting Compose.
Now that we've shown you how to easily update your apps or build new UI to be resizable, let's talk about testing and maintenance. We know that maintaining UI across all form factors can introduce test complexity. We're adding new testing and automation tools and APIs to allow you to scale your testing across more device profiles without significantly increasing the burden of doing so. It's difficult to own physical devices representative of all screen sizes and form factors. We sought out to provide a quick, seamless approach to run existing instrumentation tests on a variety of screen sizes and API levels through virtual devices. With Gradle managed devices, you can simply describe the configuration of devices you want to run your tests on, and Gradle takes care of the rest, including device provisioning and test execution, to create a consistent, reproducible testing environment. Simply define devices in your build script, and add them to a device group, such as a group of devices with medium and expanded width size classes. Then, use the group of Gradle managed devices to run your tests. Because Gradle manages both the device provisioning and test execution, Gradle managed devices also supports test sharding, which allows you to split your tests across a specified number of identical devices, reducing your overall test execution time. Simply pass this flag to specify the number of identical instances of each device that you want to shard your tests across, and Gradle takes care of the rest. But we know that running a large number of virtual devices can be taxing on your CPU and memory, potentially limiting the usefulness of Gradle managed devices and test sharding. To help, Gradle managed devices introduces a new type of virtual device that is optimized for instrumentation tests called automated test devices. These devices run in a headless mode with disabled background processes and services that you typically don't need for automated testing, reducing your overall CPU and memory usage per device. This will allow you to run tests targeting multiple devices representing different screen sizes simultaneously. Currently, ATDs are available for Android 10. Higher API levels will be supported over time. And to make sure that your existing screenshot tests continue to work with automated test devices, we've updated the Android X testing library with screenshot APIs that dynamically toggle hardware rendering only when required to capture a screenshot, ensuring that automated test devices run as efficiently as possible. While this is a lot of great functionality for how you run your tests, we're also thinking about how to help write better tests. In particular, testing your app through configuration and device state changes in a synchronous way has always been challenging, and it becomes even more important to write these tests for large screens and foldables. To help, we're working on a brand new set of Android X testing APIs that allows you to put the device in different states or postures. For example, you can test how your app reacts when the device goes from being folded flat to half opened, or is rotated between portrait or landscape modes, all with synchronization built in. We're still gearing up for a preview release of this API to first work with virtual devices, so look out for announcements soon.
We've covered a lot of ground today, from talking about new design guidance and window size classes to specific APIs for updating existing apps, such as sliding pane layout support and navigation, new UI in Compose, and overall testing tools to help you scale your UI to larger screen sizes. Large screens and foldables represent such a large and growing segment of Android. To take advantage of this momentum, now is the time to build and design UI responsively, so users on our most premium devices have a great experience. We're excited to see how apps can evolve and what else we can do to help you seize this opportunity. There's a lot of new features coming out across Material Design, 12L, the Play Store, and Jetpack to help you in your large screen journey, and we've only covered a few today. Check out the talks on large screen updates for Android and Chrome OS, Material Design, Input, and Jetpack Compose layouts for more details on specific topics, and our newly released large screen guide, where you will find everything we've covered today and more. Thanks for watching!
Hello, everyone, and welcome to a new Ask Android session. This time, we're focused on large screens. So if you have questions around the new 12L feature drop, building for large screens using Jetpack, designing for large screens using Material Design, use that live chat and ask us our questions. We can't wait to unfold all of these topics. I'm Frena Montanescu. I'm a developer relations engineer. And here with me, I have...
Hi, everyone. My name is Daniel Jacobson. I'm a product manager and Android developer, and I'm focused on making it easy for developers to build applications for all screens, especially large screens and foldables.
Hi, my name is Javier Lopez. I'm a designer in the Material Design team, and I've been leading the efforts on large screen guidance.
Hi, I'm Wale Ogunwale. I lead the Android Window Manager team as part of the Border Framework team.
And I'm Chris Damaris. I'm co-founder and head of engineering at LumaTouch. We're really excited to be bringing our video editing app, LumaFusion, to all the incredible large screens that are available on Android and Chrome OS.
Cool. Thank you, Ron. So until you get started with asking us questions on the live chat, we'll start with some of the questions we got asked previously on Twitter. And the first one is, the large screen segment has existed in the industry for some time now. What new opportunities do you see? What new use cases or products? If I can start this one, I think what's incredible is actually the growth of Android tablet activations. So I think in the last year, it was what, like 100 million new Android tablet activations, which is a lot. And then we've seen, I think, over 250 million active large screen devices running Android. That's, I don't know, that's such a huge market that I think, I don't know, you shouldn't miss out on building for that market. And now with the increased usage of foldables, it just increases the way you can build, the way, I don't know, the opportunities you can have of expanding your app beyond the phone factor. Anyone else wants to add some more things?
Well, we're also
yeah,
really,
I think. Please, Chris, you should go first.
Yeah, I'm just going to say that we're really excited, honestly, by Chromebooks, just because that gets us into the educational market where those are so important, and that's a really nice area for creative tools like LumaFusion.
It's just about that bigger screen, right? Bigger real estate.
Yeah, our app is definitely built around its best use cases on a large screen, because there's a lot to do when you're editing a video.
Javier?
Yeah, from the design perspective, what was interesting about considering a large screen device is that, yes, of course, they've existed for a long time, but what was unique about specifically the foldable is this idea of going from transitioning from an app that may look like a regular phone to something that is much larger. So that really opens up the opportunities for designers to fit in more, right? Like, it doesn't necessarily mean that we're going to put more content inside or like jam pack the screen, but instead it was really good opportunity for us to introduce different functionality, or even displaying elements next to one another. And the other thing that is that we identified as a really big opportunity for anybody that is transitioning into these is that there's a lot more opportunities for multitasking, and users are confronted with more complex tasks in their everyday lives. So these devices really are good opportunities for us to like start thinking about what may your app look like next to one another, how can your app work with another one, or even how may you think about like the transition between all of these postures in the device or even on a tablet.
We can go then to the next question. What optimizations do developers need to consider for large screens? What should developers think of? Daniel, do you want to take this one?
Sure, that's a great question. So I think it's a bit of a mindset shift, where traditionally you're thinking about building an application that's probably just going to run on a typical candy bar phone style device, to thinking about how your UI can run no matter what the size is. So obviously large screens are important, but I think one statistic that blows my mind is the 7x increase in multitasking on foldable devices because of the larger screen real estate. And when an end user is using those applications, they can resize it to be whatever they want. And so really just consider how your application will scale no matter how it's being used. And so more obviously that's very vague and philosophical. Getting into more specifics, we're trying to make it easy for you. So we have the new Windows size class viewport breakpoints, where you can really think about 3 width-based breakpoints. If you optimize your layouts for those, you'll have some assurance that your application is going to run great in most use cases. And then obviously we have foldable postures where you want to think about advanced layout support and things like that. But maybe I could pass this one to Chris as well, just to talk about what sort of layout optimizations LumaFusion has made.
Well, the first time I got to try a foldable, it was really exciting because we started by capturing some video in the folded mode like a phone, and actually started editing right there in LumaFusion. Then flipped it open, and suddenly we have the full real estate of LumaFusion to be able to do more and do more easily. And we even have users who, multitasking is a great opportunity here. We have users who have use cases where they might have a script or something else they want to have up while they're using LumaFusion, and this suddenly gives them more real estate to do that. And so it's quite a nice opportunity.
Yeah, so when I think about optimization, is also think about if you're using a foldable, right? Your users are using the app with the device folded, but then when they unfold the device, you have to make sure that you have this nice app continuity. And ensure that your app displays and looks nice as well. And similar, if I'm not mistaken, starting with Android 12, apps run in multi-window mode. So then it's just, I think Javier was talking about multitasking. It means that you have to think about your app being able to be resized pretty much at any time. So how would you be handling this? I think these are some of the optimizations you have to keep in mind.
I totally agree with. Sorry. Yeah, I totally agree with the points you're making. I think for a long time, a lot of apps have been developed for phones, and phones are normally in portrait mode. And once you start transitioning to a larger screen, landscape is very important. So one of the very few things you can do to support large screens better is to make sure your app looks good in landscape mode. And if you have that covered, the next good thing would be resizability, making sure your app supports resizable activity flag, so that as it transitions from different screen sizes, it still looks good. Javier?
I think Wale said it very well. And adding on to that, the other thing that we identified as a key opportunity is navigation, right? So some of the navigation components on Portrait are optimized for the candy bar, right? Like they want to sort of stay docked to the bottom of the screen. In foldable devices or even in larger devices, that's not really the case anymore. Users are actually holding the device with two hands most times. So that means that the navigational components most likely are better positioned on the edges on the sides of the device as opposed to on the bottom. So, and another key thing that I would advise for anybody looking into doing this is really thinking about what we call the banding effect, right? Like on the candy bar, there's a whole bunch of components that extend from or elements that extend from edge to edge of the device. Which makes sense, right? It's a portrait mode, like Wale very well said. But on a tablet, then all of a sudden, things that extend from edge to edge are take up a lot of space, and they're very noticeable. And sometimes they actually can make it feel clunky. So make the UI feel clunky. So in that case, what we recommend is really trying to undock things from edges and think about other ways in which we can position your components and elements as well.
What's the easiest way for developers to optimize the application's UI for all screen sizes?
Yeah, I can try to take that one first, but then I'll probably hand it off to Wale as well. So you kind of had different options, and there's no single answer to this. It depends on where your application is today and what your future plans are. So for example, if you have an existing application based on multiple activities, well, with the 12L feature drop, we now have activity embedding for you to place multiple activities being displayed at the same time side by side. So that's a great way for you to optimize your application without having to rewrite all of your layout code and rewrite your entire application. We've also seen some promising results with Jetpack Compose as a new way to easily build resizable UI. So if you're considering rewriting a part of your UI or your entire application, Jetpack Compose is a great option that makes building resizable UI easier to do initially, easier to maintain in the long run, and things like that. So it really just depends. But just stay on top of all the news that we're announcing. We just announced a whole bunch with the Android Developer Summit, and more is coming soon. And maybe Wale can talk a little bit more too. Like there's also compatibility modes if you really don't want to do a whole lot, but I'll hand it off to Wale as well.
I think plus one to everything you said, Daniel. If you're looking to optimize, those are the first things that I would highly recommend somebody look at, especially Compose. The other options, there are some apps that have mostly been built around activities, and it takes time for them to migrate to things like the various layouts we want. With that in mind, we've built the activity embedding infrastructure in Window Manager Jetpack that allows you to have multiple of your activities on screen at the same time, mimicking some of the layouts you find in other Jetpack libraries. On top of that, we've added lots of compatibility mode to make things easier for you. The compatibility modes don't offer the ideal experience for the user. So even though it makes it usable, it's not the best experience they could be getting out of the app. So I highly encourage you to look at some of the other tools that Daniel mentioned.
And I would also add, just go to material.io. We just published a whole bunch of guidance around this, and we're hoping that it can be helpful in your journey on adapting.
Thank you. Next question from the live stream. Should I use bottom navigation on a tablet or foldable? And actually, we got another one also related to navigation. So I think it would be great to discuss around a little bit about, okay, how do we handle navigation? I think both from a design and maybe also from a developer perspective. So I think I'm going to start with you, Javier, because I think the initial question was around design.
Sure. This is a question that we get often, and I was actually hinting at it earlier. One of the things that we're recommending is that we transition the component, the bottom navigation component, into a navigation rail. A navigation rail serves a similar purpose in the sense that it has multiple destinations that are principal destinations within the application. And the idea of this is that we actually are positioning our components on the edges of the device. We think that placing navigational components on those edges are easier to reach to, and especially for people that frequently move around the application. The other thing that is important is that when it comes to secondary navigation, is really kind of a tricky one, right? Like so. In a mobile device, we may see things like tabs or even segmented buttons as things that we can use to actually have a secondary level of navigation, and those still apply in foldable devices, so they can still be used in combination with the navigation rail.
Cool. And in terms of how you would do that, you have multiple options. So in the talk actually immediately preceding this AMA, we went through two examples, one with views and one with compose. For a views-based application, you can use resource-qualified layouts. You could have a kind of compact, narrow layout using bottom navigation technologies like a bottom app bar or a bottom nav rail, bottom nav menu, sorry. Or you could then use a navigation rail for wider layouts. Another thing to think about is how this maps to design guidance. And so rather than having to guess, like, what is the breakpoint for when you go from compact to the next thing, like when you should actually do the switch, we now have the window size classes and guidance. So for compact layouts, you should use a bottom navigation menu. And then for medium and above, you should consider using a navigation rail, because that's when the user is likely going to be using the device with two hands instead of one.
Yeah, so we have, when we talk about window size classes, we have, what is it, like compact, medium, and expanded. And I think these are breakpoints that we end up using both in our guidance, in design guidance as well, but also in our tooling, right?
Yep, tooling and samples, you see it everywhere. Go ahead, Javier.
And I would also add to the window size introduction and on the design side that it's been super helpful for us to actually decouple the use of a navigation of window size from breakpoints, right? And the idea behind this is that, as Daniel actually very well explained it to me in a conversation a while back, was that like the window sizes are really helpful for triggering device component adaptations and transformations, but they're not necessarily helpful for grids or the rest of layout. So when it comes to things that people are used to correlating, say breakpoints, like grids, like the amount of columns, like margin values, those are still available, but they're just not joined to the decision of the window class. Instead, they actually just depend on the size of the screen that you have in front of you. So that way we can actually start to make smarter decisions as far as like what components get surfaced when automatically.
I think actually your answer kind of ties in with the next question we have, which is what are the differences between the 12L tablet and desktop device class / reference types? What bucket would detachable Chromebooks like the Duet fall into? Yeah.
Sure. So the device classes or the reference types, I think you're talking about some of like the reference devices that are coming in Android Studio. And so those are supposed to exercise different kind of layout states and breakpoint combinations. So the tablet reference device demonstrates what a medium height and expanded width device would look like in landscape, whereas the desktop would be expanded height, expanded width. And that's really just thinking about screen sizes. So one other thing that you need to think about when considering detachables, especially and desktop device types, is input. And a lot of times with these larger tablets or larger detachable desktops, you may have a stylus And then you also, if it's detachable, that kind of implies you can also connect it or attach it to a keyboard. And so you should consider keyboard optimization, stylus optimizations, mouse, things like that. And there's actually a talk about that. One of our coworkers, Emily, did an Input for All talk that I would highly recommend watching if you're curious to learn more about some of those optimizations. So it's a different type of thing. So there's layout and then there's input, and both are important, especially as you start thinking about larger screen devices.
Actually, Chris, I'm curious. So what did LumaFusion do? Did you folks do anything separate for these device size classes?
Well, we actually didn't, and we'll probably be taking advantage of some of the newer things soon. But what we did is really looked at the app in the term of fragments, and we did started with just two basic layouts: a portrait layout and a landscape layout. And our app really works towards that, where we have the library, the viewer, and the timeline, and those have to be related to each other. So just using a constraint layout to arrange those, and then within those fragments, doing basic simple layouts of the individual elements and treating those as almost separate apps that are their own resizable apps. And by doing that, it really simplified just the concept of it. So no matter what we do already, it was working quite well. And then when we started looking at foldables, it's just a matter of looking at where is that occlusion area and moving our controls, and our constraints to, accommodate that. And now we're even looking at some things of what could we put in that occlusion area that would be interesting, like maybe metadata for the current selected clip and things like that. So there's, again, some fun opportunities to add some more data that in a normal space that you wouldn't normally think something should be there. So.
Maybe I can actually give a bit more information on some of the things that you mentioned, because I know when I started working with foldables, I didn't really know what is that occlusion area that you're talking about. And I also think about postures. What are these postures? So I think when we talk about foldables, you have multiple postures. You can use the device folded, unfolded, but also in something that we call tabletop mode. So when the device is half opened. So these are all our postures. But then when the device is in something like tabletop mode, then you have parts of the screen that can be occluded, right? That are not touchable. And therefore, those are areas where information like metadata that you just mentioned, Chris, would be great to be displayed. And actually, also, this goes into the next question, which is, how can I handle foldable postures like tabletop mode? So now that we said what these postures are, who wants to talk about how to handle them?
I guess I can. Oh, go ahead, Wally. I was hoping you would.
So we have a Jetpack library called Window Manager Jetpack, and that has all the tools you need to handle various postures. We actually just went to beta, I think, within the last few weeks, so that's pretty exciting. We've been working with the industry for a couple of years now to finalize and to polish the API surfaces for all the foldable devices. As you all know, it's been kind of crazy, a ton of foldable devices of all shapes and sizes. And it's been also exciting, and it was a little bit of a challenge to get our API surface to be able to cover every single case. And now that we're in beta, we feel we're in a really good place. And y'all give it a try. Give us feedback, and we can always make it better.
Yeah, I think we're at beta 03, and then I'm hoping for a stable release soon. But yeah, I know we can't promise, but it's hopefully we're getting close to a stable release.
Fingers crossed.
I would also add that when it comes to postures, it's very important for people to consider not only the fact that components may actually just transition into their new this larger device, this larger screen size, but especially when we go into tabletop posture, we actually do need to take a special care of the UI. By, say, placing key actions or most actions at the bottom of the screen, and then most consumption, components that would actually effectively be for consuming content on the adjacent screen. The idea behind that is that, as a user may actually have something in tabletop mode, which is similar to how a laptop would actually look. Then tapping on the screen on the vertical screen actually makes the sort of jiggles the phone, right? And same thing, the camera is actually positioned in that side. So if you actually would be to place anything where you need to look at a camera on the bottom of the device, and it renders it kind of impossible to see. So those considerations are very important to take, especially when we actually think about the ergonomics of actually changing a posture.
I know we're talking a lot about guidance here. I just want to remind that we have all of this guidance out there. So when it comes to design guidance, I think that's on the material.io website. And then when it comes to building, to the implementation, then on developers.android.com, we've actually recently updated a lot of our docs to provide guidance on how to build for large screens, both using views, but also Compose. And then when it comes to building for foldables, we actually have a code lab that allows you to actually do some hands-on work and try out all of these window manager APIs. Cool. Next question. On devices like Chrome OS, where the user can resize a window from compact all the way to expanded, it is jarring for the user to have the navigation switch from a bottom to side rail.
I guess I can start, and then I'll look to Javier for some design support as well. I mean, I think if you think about this more generically, just in terms of resizable apps, like it might be a bit jarring for that transition for a second. We are working on ways to actually smooth the transitions as well, but then you actually produce just a better user experience in that new layout state, and that's really what's important. Is like whenever you have the given screen size or the available real estate, like what is the best user experience you could provide? Another example is a foldable with an outer display. You have a small outer display, and that will almost guaranteed have a bottom navigation bar because it's like a typical phone. And then when you unfold it, it will probably have a navigation rail because it's going to be a bigger display. And we haven't seen that to be jarring or atypical. Like people, you seem to pick up on it right away, and it's great. But maybe there's some design research that has gone into that as well. Javier?
Yeah, I think from our perspective, one of the key issues that we found is that if we did not do that, then we were actually sacrificing a user experience by keeping these navigational components on the bottom. So we have actually tested quite a bit on the motion of opening and closing or sort of expanding a screen and contracting it. And the thing that we're realizing is that yes, it is a noticeable transition. But once people actually get into the new context, and it works the same. The other part is that yes, of course, it's going the moment that it happens, it may actually be jarring, especially if you keep changing it. But the majority of our users actually don't necessarily change the screens, the sizes of their screens as much, right? Like so, typically you may actually go one or twice, but that's not necessarily a thing that people continue to do on like say every minute or so.
Yeah, we find, with LumaFusion, users resize the window when they want to do a different kind of workflow. For example, when they do want to put something next to it for, let's say, looking at a script. And so it's going to be a one-time change. They'll stay in that mode for a while and then switch back. And the context switch of the UI is actually good in the sense that it leads them to, a different workflow that they're working on at that point.
What are the trade-offs of using the new 12L activity embedding versus alternate ways of building larger screen apps? Is there a preferred architecture when starting from scratch? Wally, would you like to start talking about activity embedding?
Definitely, excellent question. The main reason we invested in activity embedding is to help people that already have existing apps based around activities. If you're starting from scratch, I highly recommend looking at some of the other Jetpack libraries like Compose. They offer excellent foundations to build you up for this environment and a ton of other environments Android runs on. If you have an existing app that uses a ton of activities and you would like to make it look better or larger screens, activity embedding is an easy way to do that.
Yeah, if I can add to that, because of activity embedding, you also don't need to re-architect your app, right? Because you already have, let's say, multiple activities. So activity embedding just allows you to display multiple side by side. So it's easier. But if you actually already use fragments, or hopefully you already use Compose in a single activity app, then don't use activity embedding, but rather, I would say, check out the build UIs for any app. I think the talk that Daniel and Clara gave, and also our guidance to see how to implement it.
Just a quick add-on to that is we have different solutions depending on where you are in your app journey.
Some apps have a ton of legacy code and they've been building up their app for years and they have multiple activities. We don't want to exclude you from being able to easily support these different devices. So like we're targeting new solutions and technologies no matter where you are. But like Wally mentioned, Compose is obviously where a lot of our current investment is going, and it's the modern UI toolkit for Android. And so if you're starting from scratch, that's a really great place to start.
And our last question on Chrome OS, but I think this might apply for general large screens, not just Chrome OS. When my window resizes, how do I make the components of my app move smoothly to the new dimensions? So not just the navigation rail, but all components.
So that's like I mentioned. Oh, go ahead, Javier.
Oh, no, I was going to say that like this would be a really good plug for Material.io. We have actually added some guidance in terms of motion with some transitions that are default transitions coming from our motion subsystem, which should be useful in this regard. We have paid special attention to foldables because they are the places where we see the majority of these transitions. Obviously, this applies as well to Chrome OS. But one of the key things that we're finding is that as people actually move their devices or transition from one state to another, it's usually important for us to keep at least one element that helps people sort of situate or understand the context in what's changing and what's not. In our case, we've been playing a lot with sort of components like, say, search bars or the position of our fab, which tend to be almost like landscape sort of signifiers within the app, and those are very helpful to target. The other part is that what is possible from the motion system actually makes it really useful, so that in this case you can actually just sort of plug and play and start using it.
Cool.
Just to add to that, from the technical side, on the order view system or toolkit, it's a little bit difficult to have those kind of transitions to be smooth and to cross configurations lines and whatnot. It's a whole lot easier on Compose, and if you're starting from scratch, you have the opportunity to use Compose. This is one of the areas where it's actually significantly more powerful and beneficial. Whereas I was still looking at the order toolkits to see if there are things we can do there to also improve these smoother transitions.
Cool. I'm afraid we have to wrap this up. Thank you, everyone, for watching and for asking questions. Yeah, and happy Android Dev Summit. See you all soon.
Hi, my name is Emily Roberts, a developer advocate working on Chrome OS and Android devices with large screens. Big display sizes are here and getting bigger and more varied. Phones, foldables, tablets, detachables, Chromebooks, Chrome boxes with external displays, Chrome bases with integrated monitors, and more. And we are investing heavily in the Android framework, Jetpack, and Chrome OS. There has been a growing popularity with users for more screen real estate, and with nearly 100 million new Android tablets and a 92% growth for Chrome OS just last year, and with more than 250 million large screen Android devices currently in use, your app needs to be ready. In response to this growing momentum and to support apps on these devices, we are introducing 12L, a special feature drop just for large screens. We have been working with developers to understand their needs when it comes to developing for large screens, as well as upstreaming changes from OEMs to create a number of feature and API improvements that will land early next year to make Android 12 work even better across these devices. 12L includes a number of specific enhancements for developers, improved multitasking, a redesigned look to get the most out of the extra space, and compatibility modes to make small screen apps work better. From Android 12 onward, multitasking is the order of the day, and all apps will now run in a multi-window mode. The main thing to know about this is that your app may be running in a split screen or in a window beside another app. This is especially important to keep in mind if you are rendering your own UI elements or need specific window dimensions, or if your app needs access to exclusive hardware devices like cameras and microphones. To support multitasking, 12L brings updates to the UI, including an improved taskbar for app switching. We know that in the past, getting into split screen mode was not always easy for users. The new taskbar simplifies quickly switching between apps and finding your way back to the home screen. On larger screens, the taskbar makes it easy to drag apps into split screen and multi-window modes. Because all apps will now be able to be run in a split screen mode or a separate window, regardless if they are declared to be resizable, it is important to update your app so that it can seamlessly adapt to size changes without being restarted or put into a compatibility mode. The taskbar also moves the 3-button navigation bar to the side of the screen to make things easier for users holding a large screen device. 12L also brings a number of user interface updates to the system UI. This includes better home screen layouts, an overhauled notification look and feel, and bouncers to make things like pin input easier to do. Your app will automatically take advantage of the new system look with no work needed on your part. We are also updating system apps like Settings and the Setup Wizard to make better use of screen space. If your app is locked to a portrait or landscape orientation and is not resizable, it could get shown in a compatibility mode when users enter split screen, a foldable device is unfolded, or when it is used in a multi-window environment like Chrome OS. This helps make sure apps look and function as originally intended. We are making updates to the functionality as well as the styling and presentation of compatibility modes. And while all this means that non-resizable apps will continue to work for users and will integrate better with the system, it will still not provide the ideal experience. It is up to you to optimize. We will also be making some updates to the Play Store to help users find the best apps for large screens. First, we're separating out ratings and reviews for apps on large screen devices. Secondly, we're updating our quality process to check for app resizability and layout on large screens. We are also going to be looking at input support and other features for large screens. This will allow us to surface apps to users that provide the best experience for their devices. You'll hear more about this next quarter as we prepare to launch these changes in 2022. The 12L feature drop comes with new APIs and a new SDK level, 32, to allow you to easily target the new features. Note, the annual Play Store requirement to increase your target SDK will apply to Android 12 only, so SDK 31, and will not require you to move to 32. Start testing all these new features and APIs today. Get the 12L developer preview and prepare your app for the public release early next year. You can also use the Android Studio emulators with the 12L system image. Don't forget to try out split screen, fold, and rotation events to make sure your app looks great throughout common user journeys. There is nothing like testing on real devices, and soon you'll be able to test out these features on the Lenovo P12 Pro and the Samsung Galaxy Z Fold 3. We are pleased about all the 12L updates and look forward to continuing to add even more great features and large screen support in upcoming releases of Android. I'm now going to pass it over to Andri to talk about Jetpack updates.
Jetpack Window Manager is a library that gives you backwards compatible APIs to work with window metrics and sizes, and it's now in beta. It also provides detailed information about display features like folds and hinges, and device configurations. We'll cover the stable APIs available in the library, and we'll take a look at some of the new experimental tools in the current and upcoming versions to help your app look great on large screens. The library takes advantage of the latest features in 12L, but also works with prior platform versions down to API level 14. Let's start with window metrics. In Android 11, a new set of window manager APIs was introduced to give you accurate measurements of the current window your app is running in. On large screen devices, it's very likely that your application won't be occupying the entire display, since the users engage in split screen and other forms of multi-window much more often. On the Samsung Galaxy Z Fold series, we've seen a 7x increase in split screen usage. Another example is when the window is letterboxed on a large display in a different orientation. it's important to make your app fully resizable, so we've got a whole talk dedicated to that. But how to know the size of your activity? The Window Metrics API returns the correct pixel size of the window in all possible states, and brings this capability all the way back to SDK level 14. It also informs you about the maximum possible metrics if the user expands the application display, so that you can select the right resources to load ahead of time. Remember, window metrics can change at runtime, so the recommended way is to update the values when the activity is first created and when the configuration changes using Window Metrics Calculator. Do not use the deprecated display APIs like getRealMetrics or getRealSize, or you may get unexpected size values. Another key component to making your app intuitive for users on all device form factors is to provide different layouts. We've heard your feedback that knowing which screen sizes to develop for is difficult in our diverse device ecosystem. Now, Jetpack makes this easier than ever with window size classes. They have been introduced to provide opinionated layout breakpoints for you to know how to adapt your UI. Window size classes will be useful both when selecting the right layouts for different device types and when responding to window size changes in multi-window. Historically, users mostly interacted with one app at a time in Portrait, but tablets are commonly used in landscape, and with foldable devices and different multi-window modes, it will be more common for apps to go through large and small window sizes in a single session, and it's best to support as many as possible. Look for these in Window Manager Jetpack 1.1 and learn more about building Android UIs for any screen size talk. There is a big potential for innovation, especially on foldable devices. With an increasing number of those on the market, you can get one step beyond just making it compatible with large screens and adapt to different device states when users fold or unfold while the app is running. Supporting different modes will bring new ways to interact with your app and new experiences to enjoy. For example, one common posture on foldable devices today is tabletop, best for watching videos or taking calls hands-free. The device is positioned so that part of the display is at a comfortable viewing angle, and part is lying flat on a stable foundation, making it suitable for interactive elements. Let's take a look at how the library can help you with it. To determine the posture, you can use Folding Feature, a class that enables you to monitor the state of a foldable device. An application can receive events when there is a change in the device's hinge, and use the feature type, orientation, and state to update the UI around it if necessary. There are two possible states, flat and half opened. For flat, you can consider the surface to be open entirely flat, though in some cases it may still be split by a hinge and not fully continuous. For half opened, the window always has at least two logical areas. The information about feature layout is provided via Window Info repository. To start and stop the event collection, we can use a lifecycle scope, tracking while activity is visible. You can then use the information available in the Window Layout Info object to update your layout. Folding Feature includes information like hinge orientation and state. We can use these values to check if the device is in the tabletop mode, half open with the hinge horizontal. To learn more about this, check the complete guide on building for foldable devices in our documentation. And there is a dedicated talk about optimizing media applications. Look for best practices for video apps on foldable devices. To make maintaining these new layouts easier in the long run, we also have new test APIs in Jetpack Window Manager. We introduced a dedicated window testing module in the library. Here's an example of creating test instances of the main classes. Notice that activity is the only parameter in folding feature function without a default value. The current default configuration for a test folding feature is set to be horizontal across the middle of the screen, and it is half opened. Window Layout Info Publisher rule is useful for testing UI and how it responds to folding features. You can chain it together with an activity scenario rule. The Publisher rule does not fully replace an end-to-end test in a device though. For example, a real device will update Window Layout Info for orientation, but when using the Publisher rule, you will have to update the window size and window layout info yourself. After the test rule has been set up, you can use the override window layout info method to replace the current layout info object. Now that we've covered the stable features, let's explore the new experimental additions to the library. We recognize that converting existing legacy codebases to support large screens may be challenging. For some applications that have over time invested into using activities for individual screens, switching to multi-pane layouts via fragments or other tools may incur significant refactoring and a lot of team resources. In order to make this transition easier, we are introducing Activity Embedding, a set of window-managed Jetpack features for modern large-screen devices that allow flexible organization of activity windows. Its first UI implementation is focused on taking advantage of large screen space by showing activities side by side in multi-column layout. For example, you might have separate activities for these list and detailed screens, but you'd like to show them together on large displays. While we recommend you to re-architect your app to use a single activity, we understand it's pretty costly. This feature enables you to optimize for large screen layout with the app structure you already have. And the most exciting part is that adopting the feature may require little to, in some cases, no existing code modification. Let's take a closer look. The feature is designed with compatibility in mind. The library automatically chooses the right presentation type based on the available screen space and the settings you provide. This allows avoiding branching in your in-app navigation code to handle small and large screen in different sections. The library also supports screen and window size changes at runtime. So if the user folds or unfolds the device or resizes in multi-window, the presentation is automatically updated for you. We're also staying true to the existing ordering of activities in your application. We identify two containers or activity stacks in each split, primary and secondary. The secondary container is always considered to be on top of the primary one. If the screen space is small, it will be the same stack of activities as usual. But if there is enough space, these two stacks can be shown side by side. Here's an example of what happens when you have multiple activities in the secondary container. They automatically show up within the same bounds when they were launched. The existing activity launch and intent resolution rules apply. The library also supports navigating deeper than one level, creating multiple splits. It always shows at most 2 panes, shifting the earlier creating panes off screen when launching the new ones. In this example, if you have an existing split with activities A and B, and you want to put a new activity C to the side, it creates a second split with B and C. Once again, the container will be considered on top in terms of Z ordering. This ordering means that when the user closes a foldable device and continues using the app, you can resize and reposition the container, maintaining the order of activities. The top activity in the secondary stack will be automatically expanded, but ready to be shown side by side again if the user unfolds the device. There is one different use case, which we call placeholders. Sometimes an application would show a top-level navigation list in the main page, and there is no secondary content to show until the user makes a selection. However, in order to make the best use of available space, and for consistency, it would make sense to still show a split immediately after opening the app, but maybe leave secondary page mostly empty. On the other hand, when starting on a smaller screen and after folding the device, we don't want to show an empty page on top. We added a dedicated option to support the placeholder use cases to the library. Let's check how to integrate the feature into your app. It just takes a couple of steps. First of all, declare the library dependency in your build file. Next, create an XML file in your assets and provide the rules defining which activity should be split and the properties of the splits. In this example, I want to put activities A and B in a split when B is launched on top of A. To do this, I add a single split pair rule with default configuration and a single filter that is used to match activity component names. When activity B is started from A, the filter will be checked and matched, and the new split will be automatically created by the library. We are giving you flexibility by providing different types of rules for different scenarios. You can find out more in our documentation. Alternatively, you can use the runtime APIs to add or remove the rules if necessary. Next, we need to inform the library about these rule definitions. In this example, we are using the Jetpack App Startup library to perform initialization before other components of the app load and activities start. In order to do this, we add the library dependency in the build file and the following entry in Android manifest. Here, we specify which initializer class should be used. Lastly, we add the initializer class implementation. You may be familiar with the structure if you're already using App Startup in your app. The rules are set by providing the XML resource ID with the definitions to splitcontroller.initialize. That's it! The library will track activity launches that occur from different points in your codebase, check the intents that are being used and which activities are firing them. And if a matching rule is found, a new split will be created and managed by the library. This feature will be available on large screen devices that support latest version of Window Manager Jetpack extensions. You can use it today using the 12L emulator, and you can find this feature soon on real devices like Samsung Galaxy Z Fold 3. On devices where it's not available, it will fall back to regular presentation when activities always appear stacked, fully overlapping each other. So you don't need to worry about devices that are not supported yet. And you can always check if the feature is available with a dedicated runtime API. We're also experimenting with other ways of interacting with multi-display devices. One exciting example is rear display mode that allows using the high-quality primary camera for selfies while showing the preview when the device is unfolded. We are working on a new set of APIs to support the use case. Look for it among the experimental Window Manager Jetpack APIs in the upcoming versions. Back to Emily to talk about Chrome OS.
Thanks, Andriy. Android tablets and foldables are really getting big. Let's talk a bit about Chromebooks. For years now, Chrome OS has brought users the ability to easily install and run Android apps on large screen devices. Lately, we have added a number of improvements to the Android app experience, like better picture-in-picture support, a low-latency stylus library, and better presentation of apps not designed for large screens. Picture-in-picture now looks and works even better on Chrome OS. Using the standard Android picture-in-picture APIs will get you the newest appearance and functionality without additional effort. Let's quickly review those APIs. Start by indicating picture-in-picture support in the manifest file, and then engage it with Enter Picture-in-Picture mode. You could also do things like automatically enter picture-in-picture when the user backgrounds your activity by using onUserLeaveHint. Remember, you will likely want to adjust your UI in this mode, and to do that, look for the callback on picture-in-picture mode change and make the necessary changes. In May, we announced the launch of the Chrome OS Low Latency Stylus API to get you the lowest possible latency for your painting and drawing apps. Check out the API and demo app on GitHub today. Android apps that are designed only for small screen portrait phones can look and perform badly on large screen tablets, Chromebooks, or external monitors if they are stretched out to a full screen view. Issues can range from just a suboptimal layout to crashing if the app does not correctly handle multi-window or resizing events. Like on tablets and foldables, Chrome OS now has a compatibility mode that shows apps that are designed for small screen mobile devices in a phone size or tablet size window. The user can easily change the mode of this window or enable freeform resizing if they want, but the UI lets them know that the app may not perform as expected in a full large screen mode. This helps Chrome OS provide expected behavior and stability while still giving users the freedom to interact with the apps the way they want to. Ideally, users won't see your app in the compatibility mode, right? Let's cover the most important things you need to do to make sure that is true on both Chrome OS and Android tablets and foldables. Number 1, provide appropriate large screen layouts for different form factors. Number 2, test your app to make sure it handles folding events, rotation, being moved to split screen, and freeform resizing. Jetpack components like ViewModel simplify maintaining state and provide expected behaviors for your users. Be sure to test these different layout possibilities on real devices or emulators. Number 3, handle input well across touch, keyboard, mouse, and trackpad, as well as other more specialized inputs like stylus or game controllers, depending on your app's needs. A great way to dive deeper into these topics is our other large screen talks at ADS. Learn how to make your layout look great and adapt well while handling input correctly. If your app is looking great on large screens in Chrome OS already, or if you want to know more about where to start with optimization, let us know by visiting the link here. And remember, detailed documentation about optimizing for Chrome OS and large screens can be found on chromeos.dev. Foldables, tablets, and Chromebooks are becoming more popular than ever. A lot can be done to optimize your app right now, and we are excited about the new features we are releasing soon to make apps work even better. Explore the new 12L APIs by using the emulator and downloading the 12L Developer Preview today. Start optimizing your app using Jetpack Window Manager to be fully resizable with accurate window metrics, enable new features like posture detection, and make maintaining your large screen layouts easy with activity embedding and test APIs. Don't forget to add great large screen layouts and include keyboard, mouse, and other input support. And with that, you are ready to adapt your apps for large screens. Thanks for watching.
Hello, I'm Sarah, and I'm joined today by my colleague Yasin. We're excited to be here, and thank you for being with us. We appreciate the time you have invested in talking to us, sharing your experiences, and providing us with feedback. Over the next 20 minutes, we will provide an overview of the privacy changes we introduced in Android 12, share best practices on how you can make your apps private by design, and provide a look at a few concepts we're considering for future release of Android. Users care deeply about privacy. They consistently tell us that they want an OS that protects their privacy and treats their data with care. And it's no surprise, as more of our day-to-day core functionalities move to the mobile device, people will naturally seek out devices that will keep them and their data safe. And from day one, on Android, we have designed privacy for everyone. Particularly over the last several releases, we've made significant strides in keeping users' information safe. We've done this by relentlessly focusing on 3 core principles. First, by adding transparency around what data is accessed by apps and when. Second, providing simple controls for users so they can make informed choices about enhancing or limiting apps' access to their data. And third, focusing on data minimization to reduce the scope of permissions so users are not surprised by the data that leaves their device. As the Android platform evolves, it continues to provide tools and guidance to help developers integrate privacy-friendly features into their apps. For the remainder of this presentation, Yasin and I will provide best practices on how to confidently provide more transparency by making sure your users aren't surprised that you've accessed their data, how to provide controls while respecting users' choice, and how to reduce access to data by minimizing use of permissions. So let's start with the first best practice, paying attention to data accesses. As Android adds more and more transparency to the OS, it is increasingly more important for developers to pay attention to their data accesses. In Android 12, we're adding transparency to microphone and camera accesses. Going forward, users will know in real time every time an app accesses their mic or camera. By simply swiping down in quick settings, users can click on the indicators to view the apps accessing their data. If the access is unwarranted, users can quickly navigate to the app permission page to revoke the permissions. You should review your code of microphone and camera and proactively remove unexpected accesses. For example, make sure your app is not accessing these sensors before the user has clicked on the feature that needs access. Users often tell us that they want to understand what data apps are actually using. With the new privacy dashboard, users will have a simple and clear timeline view of the last 24-hour accesses by mic, camera, and location. For the remaining runtime permissions, users will see whether or not an app accessed the data in the last 24 hours. We encourage all of you to review your code path and make sure all accesses can be justified by your use cases, including third-party SDKs, which will be attributed to your app. Users care deeply about why apps access their data. The Play Store will include a data safety section to provide users with easy-to-understand information about app data usage, allowing them to make more informed decisions about which apps they want to install. Users can feel safer and more confident that developers will use their data responsibly. Please make sure you check out our ADS talk, Get Prepared for Data Safety section to learn more. We know how sensitive content copied to clipboard data can be. Users frequently copy emails, addresses, and passwords. Android 12 notifies users every time an app reads from their clipboard data. Users will see a toast at the bottom of the screen each time an app calls Get Primary Clip. The toast doesn't show if clipboard data originates from the same app. You can minimize access by first checking Get Primary Clip Description to learn about the type of data that is in the clipboard. The recommended best practice is to only access the clipboard when the user understands why. Now, to prepare for the new transparency features on Android, we recommend developers to first do an audit of their code for unexpected accesses. You can use the auditing APIs to untangle the mapping of your code by tracking which part of your code is accessing private data and track and control data access by third-party SDKs. The API instructs the system to invoke an app-specified callback each time the app accesses sensitive data. The callback provides information about the type of data being accessed and lets you record the stack traces and timing of the access. You can also provide a rationale for users to help them understand why your app accesses location, camera, and microphone information. The rationale can appear on the Privacy Dashboard UI, your app's permission screen, or both. In order to implement, you first need to add an activity that, when started, provides some rationale for why your app accesses the data. Within this activity, set the Android permission attribute to Start View Permission Usage. If your app targets Android 12 or higher, you must explicitly define a value for the Android exported attribute. Then add the intent filter to the activity. You can add Android Intent Action View Permission Usage for your app's permission page, and/or you can add Android Intent Action View Permission Usage for period for the Privacy Dashboard. Depending on which intent filter you add, users will see an information icon next to your app's name. For further information about data access auditing APIs and permissions intent, please reference a recent blog published titled Increasing User Transparency with Privacy Dashboard. Okay, so a few takeaways for developer when it comes to permission accesses. First, make sure your app is only accessing data when a feature needs it. Second, pay attention to permissions added by libraries in your merge manifest. For example, you could merge manifests to see what permissions are used by what library dependencies. Please refer to our blog post titled Getting to Know the Behaviors of Your SDK Dependencies. And third, make sure you're not excessively accessing users' data. Moving to our second best practice is to respect the user's choice. Android offers users control that provides means for them to make informed decisions about who can access their private data and how much access they're willing to share. It's about balancing choice with safe defaults. It's important that you provide the user's choice and respect their decision. Our research shows that the more informed users are about why apps need access to their data, the more likely they are to engage. For example, one recent study showed users are less likely to deny permissions when requests include a rationale. It is critical that you explain to users why you need access to their data. In Android 12, we've added additional controls for location. Next time an app needs location, users will have a clear choice to reduce the accuracy provided to the app by selecting an approximate location. We encourage all developers that need location to review your use case and only request access coarse location if your feature doesn't need the user's precise location. It's important that you explain to users why your feature needs access to location and progressively request fine. Always be prepared for the users to only grant you coarse. Your app should still work. Here's an example of an app that has two features. One that needs access to coarse location only, and another that needs access to fine location. If a user taps on a feature that needs coarse, check to see if you should present a rationale by calling shouldShowRequestPermissionsRationale API. If the API returns true, then present the user with the rationale followed by approximate location permission dialog by requesting access course location. If later the user clicks on a feature that needs find, then you can present the user with an upgrade dialog by requesting access find location. As always, make sure users understand your location use case before requesting access. In Android 12, we're adding 2 new controls, which allows users to quickly cut off all access to microphone and camera on the device. In case users launch an app that needs access to the sensors, they will be notified to quickly turn the sensors back on. This is not the same as permissions being denied. The system will take care of the end-to-end flow and will let users know if toggles are muted. Apps don't need to do anything differently. And as part of this launch, we're also limiting motion sensor sampling rates to 200 Hz. Users also tell us that they're overwhelmed by the number of notifications they get. They want to have more control over which apps get to communicate with them. In the future release of Android, we're adding a new notification permission. This permission will work like all other permissions, and it will require the user to grant the app access before an app can send user notifications. If your app needs to send users notifications, going forward, please declare post notifications in your manifest. You can check access to notifications using the existing Notification Manager or Notifications Enabled method. Please note that this is consistent with how you request all other permissions on Android. So, takeaways for developers. Number 1, please make sure users understand why your app needs access to their data. Second, always be prepared for the user or the system to deny permissions and respect users' choice when they deny the permission the second time. Third, don't ask for all permissions at once. Gradually request based on the feature a user has invoked. And finally, gracefully degrade when the user denies or revokes a permission. I'll now hand it over to Yassine to tell you more about best practices for minimizing use of permissions.
Thanks, Sarah. Being respectful of the user's choice in terms of permissions is always a recommendation for good user experience. And Android offers alternative APIs to access sensitive information with less friction and better privacy control by the user. Here's a highlight of the main ones. One way you can minimize data access in Android 12 is by adding a new runtime permission for nearby connection. Up until now, companion apps for devices such as watches and headphones required the location permission to scan for nearby Bluetooth devices. We heard from users and developers that this was confusing, and not to mention overgranting location when apps just wanted Bluetooth. Going forward, companion apps can connect to their associated devices by requesting the new nearby permission. Up until API level 30, your app had to request the Bluetooth admin permission to discover and pair Bluetooth devices, along with the Bluetooth permission to connect with paired devices and the location permission. When targeting API 31, you can set a max SDK to API 30 to these existing permissions in your manifest. And add the Bluetooth scan permission with the user's permission flag never for location, which tells the system that your app won't be using it to infer the device location. You'll also need to add the Bluetooth Connect permission to interact with Bluetooth devices, and finally, add the Bluetooth Advertise permission if you need to make the user's device visible to other Bluetooth devices. Last year, we launched Permissions Auto Reset on Android 11 and made it available to Android 6 and up devices via Google Play services. If an app isn't used for an extended period of time, Android automatically revokes permissions for the app. Since the launch, permissions have been reset from 8.5 million apps. Make sure you're always checking permissions, as the system can reset your permission grants when your app isn't used in a few months. This year, we're building on Permissions Auto Reset by intelligently hibernating apps that have gone unused for an extended period of time, optimizing for device storage, performance, and safety. The system not only revokes permissions granted previously by the user, but it also force stops the app and reclaims memory, storage, and other temporary resources. In this state, the system also prevents apps from running jobs in the background or receiving push notifications. users can bring apps out of hibernation by simply launching them. Similar to permissions auto reset, the user will be prompted when an app has gone into hibernation and can disable hibernation in settings. On the storage side, we've introduced Cup Storage on Android 10, which initiated a privacy-preserving storage approach. With improvements on the following versions, apps' external directories aren't accessible to other apps, and you can add and edit your own files without requesting any permission, while editing third-party files require explicit user consent. So if your app only adds files to shared storage, you do not need to request any runtime permissions. In the upcoming months, we'll release a new feature called Photo Picker, which allows you to read images and videos selected by the user without requesting any permission. Selectable media includes the photos and videos stored on the device, but also from cloud providers like Google Photos. By using this feature instead of custom-made Photo Picker, you can stop requesting any runtime permissions to access all photos and videos. The Photo Picker will be available on Android 11 Plus devices through a Google Play system update. To invoke the Photo Picker, you'll need to launch the Action Pick Images intent and specify both the max number of selectable media and allow types, whether photos and/or videos. Once the user has selected files, you'll get back their URIs through the clip data property and can read them via the content resolver. We will release a support library as well to abstract the media selection by using the Photo Picker when available and the Storage Access Framework as a fallback on older devices. File content reading and metadata fetching easier for developers. We're also working on bringing more clarity for users and granularity for developers with new storage permissions. On the next version of Android, the new permissions Read Images will allow you to read all images and videos on the shared storage, while Read Audio will allow you to read all audio files, including playlist files like .m3u. Thanks to Cup Storage, adding and editing your own files, whether they are media files or not, does not require any permission. Non-media files in the shared storage are still accessible through the Storage Access Framework. To apply these changes in your manifest, set a max SDK to API 31 on the Read External Storage permission, and add the new permissions based on your app's features. Managed external storage can be used for apps that have a core use case requiring a broad access to files on a device. Keep in mind that this permission is subject to the All Files Access policy on Google Play. To sum up these recommendations, request as little as possible location access and always prefer coarse than fine permission. Use the new Bluetooth permissions as they don't require the location permission if you don't need to derive physical location. And prepare your app for the Photo Picker, which avoids requesting any storage permissions by instead allowing users to choose specific images to share with your app. Thank you for watching this talk, and feel free to ping us on Twitter to share your feedback. Bye!
Hi everyone, I'm Francesco from the Android Developer Relations team, and welcome to the session Best Practices for Video Apps on Foldables and Large Screens. Nowadays, people use your apps on all kinds of devices. They expect your apps to work seamlessly on different screen sizes and form factors. There are currently hundreds of millions of large screen Android devices in use, and you can support all of them with a single code base by building responsive layouts that adapt to fit phones, tablets, foldables, and laptops. However, when dealing with video applications, there are some additional steps to take in order to improve the user experience, such as handling posture changes in foldable devices and making sure that the UI correctly scales incoming video streams across different window sizes. In this session, we are going to explore some of the best development practices, and we will have the chance to learn from two special guests that will share their journey and update their apps for large screens and foldables. Let's start with poster changes. Foldable devices offer users the possibility to do more with their phones, including innovations like the tabletop mode, where the phone is placed on a surface with a hinge in an horizontal position and the folded screen is in a partially open state. This mode is convenient when you want to use the phone hands-free, and it's great for watching media, making video calls, taking pictures, and even gaming. A great example that you can see is the optimization that the Google Duo team did on their app to work well on tablets and foldable devices. In this session, we will see how to build a very simple layout that contains a single ExoPlayer instance that automatically resizes during poster changes, with this nice animation. A simple implementation would be, for example, an activity where the root element is a motion layout that contains 3 child views: the video player, the control panel, and a guideline. You may already notice some new features that have been added in constraint layout to help manage foldable devices. Let's see them in detail. There is a new mechanism to inject runtime values using a shared value and a new element called the reactive guide, which is an invisible UI component that positions itself automatically when a shared value changes. Note the attribute layout constraint guide end. This is the value you want to change to move the guideline. Since the reactive guide is horizontal, this attribute represents the distance between the guideline itself and the bottom of the parent. With that layout defined, it's now time to make your app fold aware. Jetpack Window Manager comes to help with this task. After it is initialized, the library allows you to listen for layout changes by collecting the flow exposed by Window Info repository. Every time you get a new layout information, you can query the display features and check the device postures. A device can be used in tabletop mode if the folding feature state is half opened and the orientation is horizontal. When this is the case, you can calculate the relative position of the fold and move the reactive guide to that position, while moving it to 0 otherwise. Remember that in this case, 0 means 0 distance from the bottom of the screen. Now let's see some real-world use cases of successful layouts for foldables. I'm going to leave the word to Will Chan from Zoom to learn how they took advantage of the new foldable form factors to improve the UX of their app.
Hi, I'm Will, and today I want to give you an overview of what Zoom has done to bring our app to foldable devices. At Zoom, our goal is to make video communications frictionless, and we're always looking for ways to better connect people. Over the last year, we've noticed more people using larger screen devices on Android, so we wanted to make sure these users have the best experience possible when in a Zoom meeting. One of the opportunities we saw for improving the experience on larger screen devices was foldables. Designing for foldable devices enabled us to scale our mobile UI to address our users' needs no matter what size device they use. The foldable form factor itself allows for interesting new applications. Many of these new foldable devices can sit on a table in a tabletop mode that allows for hands-free interactions, which can be especially useful in video communication. For example, users can still be seen in a Zoom meeting while having the freedom to walk around a room. For this experience, when a user folds a device, we adjust the Zoom meeting UI so that all the controls are on the bottom half of the screen, while the video of other participants and self-view are displayed on top. This creates an intuitive video conferencing experience and provides users with a pixel-perfect UI. This way, we prevent the crease line on the screen from obstructing faces of video participants. To accomplish this, we use Window Manager and Constraint Layout. Window Manager allows us to easily switch interfaces when the folding state of the device changes. And by adopting Constraint Layout, we reduce the complexity of our layout logic while allowing us greater flexibility to design more responsive UIs. We also saw better rendering performance, which helps when there are more complex layouts. We are pleased to offer users with foldable devices a new, convenient way to use Zoom, and we look forward to integrating more Android libraries to help deliver great video communications experiences on Android. Back to you, Francesco.
Thanks a lot, Will. It's always exciting to see products that care so much about optimizing the user experience in every scenario. Now let's move to the second part of this session. I already mentioned that another important point is to adapt video streams to different aspect ratios. Two streams maybe are coming from your camera or from someone else's, from a file or from the web. Maybe a user is sharing the screen with you, but their device has a different orientation or aspect ratio than yours. If your app does not handle those cases, it may result in images distorted or with the wrong rotation. Just like we did it before for poster changes, let's consider the simplest scenario with a single video stream coming from your camera and being previewed on a texture view. And let's explore some best practices to avoid ending up destroying Leonardo's masterpiece. What you just saw can happen because by default the preview will be scaled to fit the wall surface. This behavior may cause scaling problems since the X and the Y axis may be scaled by different factors. Also, by default, the texture view does not handle display rotations. So it's up to the client application to correctly scale and rotate the video stream with a multi-step transformation. In particular, we will need to scale back the preview to its original size, applying the right scaling and then handling the rotations, with a few adjustments. Let's start with rotations. Camera sensors and camera previews aren't always in the same orientation on Android devices. Camera apps generally assume a fixed relationship between the orientation of the device and the aspect ratio of the camera preview. But these assumptions are being challenged by new form factors such as foldable devices and display modes such as multi-window and multi-display. Here we can see a code snippet that computes the rotation required in degrees to transform the camera sensor output orientation to the device's current orientation. As you can see, we want the rotation to be clockwise or counterclockwise depending if the camera is facing the front or the back of the screen. And then we basically just calculate the difference between the two orientations with some math to make sure that value is always between 0 and 360. Then we need to set the size of the texture view to be identical to the preview size chosen. This is important to avoid the default buffer size to be overwritten. Note that at this step, the preview can still be stretched out. Finally, we calculate the scale factors for the X and the Y axis to bring the preview back to the original size. And then we apply the desired scale. In this case, I'm using the minimum value, so the picture will probably look smaller than the viewfinder with black bars at the borders. Keep in mind that this code shows the general procedure, but does not cover all the edge cases. For an extensive documentation and handling camera previews, I'd recommend checking out the links at the end of this video. So, this was a simple scenario, but there are applications out there that handle multiple video streams like a charm. Let's spend some time with the LumaTouch team to listen to their experience in bringing their app to Android and Chrome OS devices.
Hi, I'm Chris Damaris, co-founder and head of engineering at LumaTouch. We're really excited to bring the powerful multi-track video editing experience of LumaFusion to Android and Chrome OS. We're especially happy it'll be available in so many schools, where Chromebooks have become an integral part of the learning and creative experience. We partnered with an amazing engineering team at Solveig, and they're here to talk about their experience, including some of the challenges they overcame and the tools and resources they used to make this development a success.
We have been entrusted by LumaTouch to build a great video editing application, LumaFusion, and we have faced a number of interesting development challenges and learned a lot while creating the application. The main thing we did to assess feasibility was to create an initial proof of concept video editing app on the Android, which is now available as an open source project that you can check out today. The demo app reads 4 different video clips, applies scaling, rotation, and transparency effects, and ensures smooth playback and correct export.
One of the most complicated challenges we faced was initializing 4K media codecs at the same time. We tried to use a software decoding solution, but performance was not adequate. So we switched to Android's media codecs API and Exaplayer, which showed a good performance. We started experimenting with different codecs initialization params and found a balance between performance and stability. The input files in the demo cover a variety of media files and effects, from 720p videos to heavy 4K videos and 60 frames per second.
This will be a great resource for developers looking to get started with multi-track editing and effects on Android and Chrome OS.
We were pleasantly surprised with the fact that adapting the application for different device families has not taken too much time. Despite the fact that there are a lot of devices on the market, the app platform is relatively consistent across device configurations, which helps speed up for our development.
We were able to overcome the performance variations issue because of the ability to configure the default LumaFusion setup to work well for a given device. For example, we can limit the ability to work with 4K videos on devices with lower performance, thus allowing it to run as users expect on a wide range of devices.
We optimized encoding for both low-level and high-end devices to achieve the best performance. There are two code paths. First, if the device is able to initialize all the required codecs with the highest performance setting, we do that. And if initialization fails in the first approach, we implemented a fallback mechanism to calculate initialization parameters that work.
We were initially concerned about the performance for multi-track editing on the wide range of devices, but we discovered that even some mid-range devices are able to process 4K media at the same time.
Another thing that was difficult to manage was syncing within a user timeline, especially with multiple high-resolution tracks and advanced effects. We developed an adaptive algorithm that finds an optimal balance between closed and exact sync.
There was work we had to do for different screens. By using scalable graphics for UI elements and by having a flexible design for UI layout, we were able to accommodate different screen sizes, including the special layouts for foldable postures.
LumaTouch has an outstanding UX experience, and we are working to make sure we deliver the best large screen possible to Chrome OS users. We are proud of what we have done and grateful for the opportunity to work on such a challenging project.
Very nice. It's great to see so many apps coming to Android and Chrome OS with a tailored UI. In the description, you can find the links to join the LumaFusion beta and to check out the source code of the demo app. Time is running out and we need to recap what you learned today. You can find additional information on poster changes, adaptive layouts, and much more on the official page developer.android.com/largescreens. I can't wait to see what you will build, and thanks for watching.
Hi, I'm Liam, a design advocate at Google working on material design.
And I'm Jonathan, an Android developer relations engineer at Google.
Android is getting bigger and better with over 250 million large screen devices running Android across tablets, foldables, and Chrome OS devices today. Many developers already build apps that work on more than one type of device, but it's not always easy to create experiences that scale well across different sizes and across the context in which people might be using them. With new form factors like foldables emerging, the need for responsive apps that work well at every size in every context has never been greater. In this session, we'll go over the latest material design guidance for apps that run on tablets and foldables. We'll show you the fundamentals of how content can best fit these varying screens and introduce some canonical layouts and patterns as a starting point for your own designs. We'll also dig into how to implement some of those layouts when building your apps. And more importantly, we'll give you tips on how to structure your app using principles of responsive UI, so that your code remains focused and flexible while allowing your app to smoothly handle any size screen. We're going to be focused on views in this session, so if you're looking for more about building for large screens specifically with Compose, make sure you see our other ADS talk, Building Android UIs for Any Screen Size. Earlier this year, we launched new guidelines on Material.io for large screens, and now we're adding in guidance to help prepare for even more kinds of devices, including foldables. Our Understanding Layout guidance has been expanded to cover the concept of layout containers, which form a framework for thinking about how parts of the UI like navigation, toolbars, and content can be arranged together across screens. Like in this example from the sample app Fortnightly, which provides a well-balanced tablet layout with all the containers described in our guidance contributing to its design. Compositional guidance walks you through how to make the most of screen space, arranging important content and actions across contexts in a way that maintains readability and preserves users' mental models, from scaling to reveal more content like expanded captions and dates, to smaller compositional techniques like how to visually group content and maintain a sense of relatedness in a denser layout. In these examples from Fortnightly, visual dividers are used to contain updated stories, while on the other side of the screen, empty space and typography are used to group news stories from various categories. We also have guidance on how to structure your layout as a series of columns, allowing for more expressive layouts that are defined in relationship to a rational grid. Right now, many apps consider the screen to be one big canvas or column with elements drawn in relation to one another in horizontal and vertical terms, maybe with an overall margin on either side. And this can work in some smaller contexts, but the problems become obvious at larger sizes. Applying a column grid to the layout allows for large screen experiences that are much more thoughtfully and intentionally organized. Experiences that feel more organic to the device and context. Second, columns improve information hierarchy by allowing you to divide the screen into clear regions containing related information and actions. In this example, you can see 3 clear regions, each leading the user's eyes around the screen to primary pieces or groups of information in the order in which they're meant to be consumed. Finally, and importantly, column grids allow for consistent response across sizes by providing a rational way to think about how content should reflow as the screen gets bigger or smaller. In this example, we can see that each of the 3 main regions reflow to keep their same hierarchy, but fill the smaller screen in a more ergonomic way. Keeping this grid in mind helps you make choices about component behaviors, choosing to swap or alter components across layouts in the ways that make the most sense for the device size and context. For example, bottom navigation can be replaced on larger screens by a navigation rail, which serves the same functional purpose and uses similar visual presentation, but positions the destinations in a more ergonomic way. Full-screen dialogues on mobile can be adapted to simple dialogues on larger screens to maintain the context of what the user was doing. When swapping components, remember that the component switch should serve a functional and ergonomic purpose for the user first and foremost. Finding the right threshold at which to change your UI is an important step in making an adaptive design. So we've defined new breakpoint values that help classify devices into predefined size classes. These are representative of real devices in the market, and they help convert your raw sizes into discrete standardized groups with which you can make higher-level decisions about your UI. For example, nearly all standard phones in portrait mode are a combination of compact width and medium height. Due to the ubiquity of vertical scrolling, for most apps it's enough to adapt according to width size classes. Soon these size classes will appear as a new API in the Jetpack Window Manager library version 1.1. We've also integrated them into our tooling in the form of reference devices starting in Android Studio Bumblebee, so implementing UIs based on them will be consistent and straightforward, and developers can move away from checking physical sizes or orientation or other signals that are prone to error. As you design and build for different size classes, think about how people are likely to be holding and touching the devices they represent. Being mindful of the device shape and size will allow you to build more ergonomic experiences. For example, on a tablet or even on a large phone, the very top area of the screen can be really hard to reach without fully adjusting your grip. Keep important actions and content in spots where they can be easily reached. Canonical layouts are a collection of approaches to common layouts which should be a big help when designing for big screens. The first is a simple combination of list detail or list grid views with or without a navigation container at the leading edge of the screen where the content begins. A supporting panel or sheet can also be used on experiences that require focused work like docs. A panel can come in from the trailing edge of the screen or the bottom of the screen to assist with tools or contextual controls. Feeds are common patterns often found in news or social apps. This template uses tiles to encourage discovery. The UX is the same as on mobile, opening an item opens a new page, but is more immersive and designed for the larger screen size. Hero apps prioritize content at the top of the screen and utilize supporting elements around and below it. This is fantastic for media-centered apps.
Thank you, Liam. Now let's talk about structuring your app to take advantage of these canonical layouts using the principles of responsive UI. By responsive, we don't just mean having parallel constructs for different screens. Apps should be flexible because they can be resized for a lot of reasons, like rotating the device, or multi-window mode, or folding and unfolding, so the app can transition from one size class to another and back again at runtime. It's important not to think of size classes as totally independent buckets. Apps also need continuity, meaning the user experience won't be interrupted, so they should never lose their place or their data. To make that possible, the app should have a single navigation graph, which is the model for the different experiences in the app and the way the user moves between those experiences. That model shouldn't change based on configurations, and a configuration change like resizing shouldn't trigger a change in navigation. Think of it this way. It would be really strange if your web browser went back a page, or redirected to another page, or changed the history altogether when you resize the browser window. Consequently, every destination should be flexible and be able to maintain its state during such size transitions. And this is where our canonical layouts play an integral role. With each destination, you can ask yourself, getting larger, what can I add? And getting smaller, what can I take away? And then choose a strategy that fits. Now, this might mean rethinking your navigation graph a little, especially if you're coming from a phone-centric design. Here's an example where we did just that in an app called Tracker, which is a Google sample that resembles a task management app. At the top level, it has a list of current tasks and a list of archived tasks. And from either of those, you can drill down to a task's details, and from there you can edit the task. There's also a button to add a new task, but actually we just use the edit task destination for that, and the only difference is that all the input fields will be blank to start. So this was our navigation graph before supporting large screens. We decided that both tasks and archive destinations should show 2 panes if there's enough space. As a result, we can remove the old detail destination. In this model, list and detail fit well together because they contribute to a single experience, which is exploring tasks. In a minute, I'll explain how we can still show the task details on a smaller screen. So now what about edit task? We could try to incorporate it into the 2-pane destinations, but editing a task is really a different mode of engagement. The user is inputting content instead of browsing. So for that reason, we kept edit separate and chose another pattern for this destination, like this dialog transformation. So this is our revised navigation graph, and each destination can gracefully adapt when the app gets bigger or smaller. You can find this sample on GitHub if you want to explore the code in more detail. Now that we have this context of growing and shrinking destinations, let's look at building a responsive UI. First, we should consider where persistent UI elements like navigation elements are positioned. Following the material guidelines, we can provide alternative layouts according to the width size classes and reposition the navigation where it's most accessible. A bottom navigation view for smaller screens, a navigation rail for medium screens, and a full navigation view for larger screens. Note how these layouts use a width qualifier, -W, and not the smallest width qualifier, -SW. The rest of the space is used for content, where we can apply the canonical layouts. For list detail, we have a dedicated widget in Android X called Sliding Pane Layout. To use it, you specify the layout width for its 2 children, and at runtime, Sliding Pane Layout will determine whether there's enough room to show them both. If there is, both panes will be at least their desired width. The extra space can be distributed using layout weight, as shown here with the list pane getting 1/3 and the detail pane getting 2/3 of the extra space. If there isn't enough room, then each pane will use the full width of the parent. The detail pane will either be slid off to the side or covering the first pane. You can control the sliding pane programmatically, and this is what it looks like in the tracker sample from earlier. When the user selects an item from the list, we receive that in a Kotlin flow from our view model, we update the detail pane's contents, and then slide it into view with the open pane call. Be sure to check out our page on developer.android.com about implementing 2-pane layouts using Sliding Pane Layout. That page covers additional details like integrating with the System Back button to slide the pane back. With a feed, we have an immersive layout showing a collection of items, so Recycler View is a great fit. We can make a big impact by changing which layout manager the Recycler View is using. Linear Layout Manager works great in compact width, but at medium expanded width scenarios, the items become overly stretched and distorted. So switching to Grid Layout Manager, or Staggered Grid Layout Manager, or even Flexbox Layout Manager is much more appealing. We can also change the individual item layouts and make certain items taller or wider than others to increase their importance and create a more interesting visual. In hero layouts, we're emphasizing one particular element and rearranging the other supporting elements around it. There are certainly many ways to approach that, but constraint layout provides the most flexibility for this because it offers lots of ways to constrain child elements, both their size and their position relative to other children. So here's a media app where the hero is constrained to an aspect ratio of 16:9, a description panel uses 60% of the width, and another element uses the remaining space. The constraints can be changed and even animated by using motion layout, which is a specialized constraint layout. For supporting panel, anything from a linear layout to a constraint layout works as a container to position the panel. One thing to think about is, when we transition to a smaller size, where should the panel's content go? So there are lots of options, like using a side drawer along the trailing edge, or using a bottom sheet that slides up, or using an options menu. Or maybe that content is just hidden completely.
When designing specifically for foldable devices, there are a few key considerations to keep in mind. First, foldables provide more than just a bigger screen. They also enable different device orientations or postures based on how folded the device is and how the user is using it. For the purposes of this talk, we'll recognize three explicit postures: closed, unfolded, and tabletop. As we'll see later, it's possible to detect other theoretical postures like book mode as well. Just like other large screens, think about how users are likely to hold the unfolded device. Similar to a tablet, there are regions of the screen that are more or less difficult to reach with your thumbs, and having a free hand to roam the screen is not guaranteed. The bottom corners of the device are a safe bet, while the very top of the device, especially in portrait, will likely be out of reach. This means that if you use components like the navigation rail, destinations that are centered or anchored to the bottom of the screen will be easier to use. Also consider the placement of the hinge and how that will impact interaction. Hinges can have a significant tactile difference or even be a physical separation between two screens, so avoid placing buttons and other important actions directly on the hinge area, which can be understood as roughly 48 dips wide on most devices. In tabletop mode, avoid placing UI elements on the hinge altogether, since it will be virtually inaccessible to users in this posture. For layouts, there are two main techniques to think about when transitioning from folded to unfolded. The first is expanding a screen. This puts into practice a simple, responsive layout that expands content to fill the screen, generally by expanding the column grid according to the material guidance mentioned before. The second technique is to add a screen. This can be the same approach as a list detail screen or just another panel that functionally complements the main panel upon which you're building. In both cases, according to the guidance at material.io, you'll want to create an 8-column grid that's split across both sides of the hinge area. When adding a navigation container like the navigation rail, the leading edge of the screen becomes compressed to accommodate the container.
Now let's see how we can take advantage of the fold at runtime. Jetpack Window Manager Library provides APIs to detect the presence of a fold in your app's window. Any activity can acquire a window info repository, which is what we're doing here inside of OnCreate. Then we'll safely collect from the flow of window layout info between the started and stopped lifecycle states. Whenever a value is emitted, we can inspect the display features and look for a folding feature specifically. So we now have information about the fold, and we can apply some recipes to see if the device is in one of those postures from earlier. Book mode will have the fold state half opened and the fold running vertically, and tabletop mode will have the device half opened and the fold running horizontally. Folding feature also has the location of the fold in the window. This is perfect for updating layout parameters when the fold splits your content view. So you can make adjustments like placing a supporting panel on one side or keeping your hero element above the fold. First, we need the location of the content view in our window, which is given by getLocationInWindow. We'll create a rect using those coordinates as well as the width and height. So now we have the bounds of the view in the Window's coordinate space. Folding feature provides the bounds of the fold, and that's already in the Window's coordinate space. So we can just check whether the two regions intersect. If they do, we convert the feature bounds to the coordinate space of the view and return it. By the way, if you use sliding pane layout to implement a list detail layout, you'll automatically get support for the book mode. Sliding pane layout will position the panes on either side of the fold as long as both panes fit. If your app has special behavior related to folding states, you're going to want to write unit tests for that. Jetpack Window Manager includes a test rule that can simulate a folding feature during instrumented tests. So for our test using views, we're adding the window layout info publisher rule, along with the activity scenario rule, and combining them into a test rule chain. In the test method, we acquire the activity through the activity rule. We then create a window feature to simulate tabletop mode, and build a window layout info object, and publish it using the publisher rule. After that, we can use Espresso and JUnit assertions to check that our activity properly handles tabletop mode. While we're talking about testing, we know that UI tests can because certain tests need to run on certain devices. So to help with that, Android Studio is adding support for Gradle-managed virtual devices. You can give this a try with the Android Gradle plugin version 7.1 and later. In your app's build.gradle file, under Test Options, specify virtual device profiles like the one that you normally manage to run from Android Studio, like this Pixel C tablet image. Gradle will then create targets that will execute your tests on the specified device. And Gradle can even download the device image as needed. To differentiate which tests are intended for which devices, we'll make a custom annotation, large screen test, and mark our test functions with it. When we run the Gradle command from before, we add an argument for the Android test runner to only run tests that have this annotation. If you didn't use annotations, you could use other filtering options that the test runner has, like running tests only in a specific class. So by combining those features, we can set consistent run configurations for our tests.
Before we end, we have a couple of additional thoughts and resources for you. Large screens present other opportunities for your app to shine besides just making your own content bigger. In multi-window mode, your app can be side by side with other apps. In addition to being responsive, think about how you can make your app more impactful in this mode, like by supporting drag and drop. Little features like that can really boost the user's productivity and help them enjoy using your app. Large screen devices sometimes come with additional forms of user interaction besides just touch. The larger the device gets, the more likely it is that users will start to use keyboards, styluses, mice, gamepads, or other peripherals. If you want to increase the usability of your app for those kinds of situations, plan to support at least some of those other input modes. We have another session called Input for All that has a lot more details, so make sure to check that one out too. With such a diverse hardware ecosystem, it can be hard to get your hands on devices that cover every shape and size. Today, the Android SDK ships with emulator images for foldable devices, and these emulators allow you to change the folding state at any time down to the angle of the hinge. The upcoming Android Studio Chipmunk will also have a resizable emulator, allowing you to freely change the app window size, so now every developer can try out their app in just about any form factor. We've also been working on new tooling in Android Studio to help you support large screens. The new layout validation tool can preview your layouts on reference devices that cover every size class, show you problem areas like text views with long lines, and recommend different UI components for different breakpoints. To round things out, on the Android developer website, we lay out a comprehensive list of app quality guidelines for large screens. These guidelines are broken up into sections, starting with covering basic compatibility expectations, like whether your app supports both portrait and landscape. Later sections focus on supporting all screen types and states, and using specific screen types or states to provide differentiated experiences. We hope you'll use what you learned today along with these new quality guidelines to build apps that delight your users on all kinds of screens, big and small. You can find all the links used in this talk in the video description. Thanks for watching and enjoy the rest of ADS.